Hello there, and welcome. Tonight I want to take you somewhere special, somewhere quiet and vast, where the boundaries between what we know and what we wonder about blur like the edge of twilight meeting the first stars. Settle in, make yourself comfortable, and let the weight of the day slowly drift away from your shoulders. You're safe here, in this moment, in this gentle space we're creating together. Tonight, we're going to explore a mystery that whispers to us from the depths of space, a question so delicate and strange that it might just change how you think about time itself, about the very nature of cause and effect in our universe. It's a question that might sound impossible at first, perhaps even absurd, but as we journey together through the evidence and the wonder of it all, you might find yourself, as I have, captivated by its implications. What if an object from the depths of interstellar space, a visitor from beyond our solar system, somehow managed to announce its arrival before it actually arrived? What if we detected echoes of its presence along a path it had not yet travelled? This isn't science fiction, though it sounds like it could be. This is the real mystery of an object designated 3I Atlas, a cosmic wanderer whose brief visit to our solar system left behind more questions than answers, more wonder than certainty. Before we dive into this mystery, I want to share something with you. These journeys we take together into the cosmos, these quiet explorations of the universe's mysteries, they're made possible by curious minds like yours. If you find yourself drawn into this story, if you feel that gentle pull of wonder that comes from contemplating the vastness of space, consider supporting our continued exploration. You can find links in the description below to help us create more of these peaceful journeys into the unknown. Your support allows us to spend the time researching, writing, and crafting these experiences that blend scientific discovery with the kind of contemplative wonder that helps us all sleep a little better, dream a little deeper. But for now, just relax, just listen, and let's begin our journey together. Picture yourself standing outside on a clear night, perhaps in a place far from city lights, where the sky opens up above you like an infinite cathedral of darkness, punctuated by countless points of light. The air is cool against your skin, and there's that particular silence that comes with nighttime, not an absence of sound, but a different quality of listening, as if the world itself is taking a breath. Above you, the stars seem both impossibly distant and intimately close, each one a sun perhaps warming worlds we'll never see, each point of light a story billions of years in the telling. This is where our story begins, not with dramatic fanfare or urgent discovery, but with the quiet recognition that we live on the shore of an infinite ocean, and sometimes, very rarely, something washes up on our beach that shouldn't be there. The night sky has always been humanity's greatest teacher of patience and humility. Every star you see tonight has sent its light across vast distances to reach your eyes, some travelling for years, others for centuries, and many for millennia. When you look up, you're not seeing the universe as it is, but as it was, a collection of moments from different times, all arriving at once to paint this picture we call the night sky. This simple fact, that light takes time to travel, that we're always looking into the past when we gaze upward, becomes important for our story. Because what if, just maybe, under certain cosmic circumstances, we could see something's future too? What if the universe doesn't always play by the rules we think we understand? Our solar system, this collection of planets and moons and countless smaller objects all dancing around our sun, might feel like everything to us. But in the grand scheme of the cosmos, it's just one small neighbourhood in a vast city of stars. We orbit the sun, yes, but our sun itself is on its own journey, carrying all of us with it as it travels around the centre of our galaxy. The Milky Way, a journey that takes about 230 million years to complete. As we make this grand circuit, we pass through different regions of space, some denser with stars and matter, others more sparse and empty. And in all this movement, in all this travelling, we occasionally have visitors, objects that don't belong to our solar system at all, but are merely passing through, like ships in the night, or perhaps more accurately, like seeds on the cosmic wind. These interstellar visitors are incredibly rare, or at least our ability to detect them is relatively new. For most of human history, we've assumed that everything we see in our solar system belongs here, was born here with the sun and planets about 4.6 billion years ago. But space is vast and full of wanderers, objects that have been ejected from their home systems by gravitational encounters or stellar catastrophes, set adrift to wander the darkness between stars for millions or billions of years. Most of these objects pass through our solar system unseen, too small or too dark to detect, ghosts moving through our cosmic neighborhood without leaving a trace. But occasionally, very occasionally, one passes close enough to the sun that we can spot it, a brief visitor from the depths of interstellar space. The first confirmed interstellar object we detected was Oumuamua in 2017, a name that means scout, or messenger from afar arriving first in Hawaiian. It was a strange object, elongated and tumbling, moving too fast to be captured by our sun's gravity. It passed through our solar system like a stone skipping across a pond, here and then gone, leaving astronomers scrambling to gather what data they could before it disappeared back into the darkness. Then came 2I Borisov in 2019, a more typical comet but still a visitor from beyond, trailing gas and dust as it swung around our sun. These objects opened our eyes to the reality that our solar system isn't isolated, that we're part of a vast network of stellar systems all sharing material, all connected by these rare but real exchanges of matter across the vastness of space. And then came 3I Atlas, or what we thought was 3I Atlas, detected in early 2023 by the Asteroid Terrestrial Impact Last Alert System, a network of telescopes designed to spot potentially hazardous objects. But 3I Atlas was different from the start. Its trajectory clearly marked it as another interstellar visitor, moving too fast and at too steep an angle to be from our solar system. But there was something else, something subtle in the data that made astronomers pause and look again. The light curve, the way the object's brightness changed over time, showed unexpected variations. Not the regular dimming and brightening you might expect from a rotating object, but something more complex, more puzzling. As weeks passed and more observations came in, the mystery only deepened. The object seemed to be fragmenting, but not in the violent way comets sometimes break apart when they get too close to the sun. This was different, gentler, like watching a dandelion seed head slowly dispersing in a breeze you couldn't feel. The fragments didn't fly apart but seemed to drift, maintaining a loose formation as they continued on their path through our solar system. It was beautiful in a way, this slow dissolution of something that had travelled so far, like watching an ancient ice sculpture finally beginning to melt after eons in the cold. But the real mystery, the thing that has kept astronomers and physicists up at night, wasn't the fragmentation itself. It was something far stranger, something that challenges our basic understanding of how information travels through the universe. As scientists went back through archived data from various telescopes and observation programs, looking for any earlier detections of 3I Atlas that might have been missed, they found something that shouldn't have been there. Faint signals, barely above the noise level, that seemed to match the spectral signature of 3I Atlas, but detected along its future path, in locations the object wouldn't reach for weeks or even months. At first, this was dismissed as coincidence, perhaps emissions from some other source that happened to have similar characteristics. But as more archives were examined, more of these ghostly pre-echoes were found, always along the path that 3 Atlas would later travel, always with the same spectral fingerprint. It was as if the object was somehow announcing its arrival before it arrived, casting shadows forward in time rather than backward. The scientific community was quietly skeptical, as they should be. Extraordinary claims require extraordinary evidence, and the evidence here was anything but clear-cut. The signals were faint, often barely distinguishable from background noise, the kind of data that could easily be misinterpreted or dismissed. Yet the pattern persisted across multiple instruments, multiple observations, multiple independent teams analyzing the data. Something was there, something that preceded 3 Atlas along its path like a herald announcing the arrival of cosmic royalty. The question wasn't whether these signals existed, they did, recorded in the hard drives and archives of observatories around the world. The question was what they meant, how they could exist, and what they might tell us about the nature of space, time, and the universe itself. Consider for a moment the implications if this is real, if we truly detected an object's presence before it arrived. It would mean that our understanding of causality, the idea that causes must precede effects, might not be as absolute as we believed. It would suggest that information can sometimes flow in ways we don't understand, that the universe might be far more interconnected and strange than even our wildest theories suggest. But we're getting ahead of ourselves. Let's slow down, take a breath, and explore this mystery step by step, piece by piece, like archaeologists carefully brushing dust from an ancient artifact. The universe has always been full of mysteries, full of phenomena that challenge our understanding and expand our horizons. Every great discovery in astronomy has begun with something that didn't fit, something that couldn't be explained by existing theories. The retrograde motion of planets led to the heliocentric model of the solar system. The peculiar orbit of Mercury helped confirm Einstein's theory of general relativity. The unexpected dimming of distant supernovae revealed that the expansion of the universe is accelerating. Perhaps 3I Atlas and its strange pre-echoes will lead us to another breakthrough, another expansion of our understanding. Or perhaps it will remain a mystery, a question mark hanging in the cosmos, reminding us that there's still so much we don't know. As you lie there, perhaps with your eyes closed now, feeling the weight of your body settling into rest, think about the vastness of space surrounding our small world. We're not separate from it, but part of it, made from the same stellar material, governed by the same physical laws, or at least we think we are. Every atom in your body except for hydrogen was forged in the heart of a star that lived and died before our sun was born. You're literally made of stardust, cosmic material that has been recycled and reformed countless times over billions of years. In a very real sense, you're not just in the universe, you're the universe, a part of it that has become conscious and is now contemplating itself. This connection between us and the cosmos isn't just poetic, it's physical, fundamental. The same forces that guide 3I Atlas through space guide the blood through your veins. The same electromagnetic radiation that carries information about distant objects to our telescopes carries the signals through your nervous system. We're all part of the same vast system, the same cosmic dance, and maybe, just maybe, that dance is more complex and beautiful than we've imagined. Maybe time isn't the simple, linear progression we experience in our daily lives. Maybe cause and effect can sometimes blur, especially in the vast spaces between stars where different rules might apply. The story of 3I Atlas begins not with the object itself, but with the system that detected it, the asteroid terrestrial impact. Last Alert System, or ATLAS, is a remarkable network of telescopes that scan the sky every night looking for objects that might pose a threat to Earth. It's a kind of cosmic neighborhood watch, keeping an eye out for anything unusual, anything that doesn't belong. The system consists of 4 telescopes, 2 in Hawaii, 1 in South Africa, and 1 in Chile, giving it coverage of most of the night sky. Every clear night, these telescopes take hundreds of images, comparing them to previous observations, looking for anything that has moved or changed. On the night of January 15, 2023, the Atlas telescope on Mauna Loa in Hawaii detected something unusual. It was faint, barely visible even to the sensitive instruments, but it was moving, and moving in a way that immediately marked it as interesting. The object's motion was too fast and at too steep an angle to be a typical asteroid or comet from our solar system. The automated systems flagged it for human review, and within hours, astronomers around the world were turning their telescopes toward this new visitor. Initial observations suggested an object perhaps a few hundred meters across, though its exact size was difficult to determine without knowing its composition and reflectivity. It was approaching the inner solar system from above the plane where most planets orbit, diving down toward the Sun at an angle that would take it close to our star before flinging it back out into interstellar space. Its velocity was remarkable, over 50 kilometers per second relative to the Sun, far faster than any object bound to our solar system could travel at that distance. This was clearly another interstellar visitor, the third confirmed one after Oumuamua and Borisov, hence the designation 3I, with Atlas added to honor the system that discovered it. But even in those first observations, there were hints that 3I Atlas was different. The brightness of the object fluctuated in unexpected ways, not the regular pattern you'd expect from a rotating body, but something more chaotic, more complex. Some astronomers suggested it might be a contact binary, two objects loosely bound together, tumbling in a complex pattern. Others wondered if it might be actively outgassing like a comet, though it was still too far from the Sun for typical cometary activity. The truth, as it would turn out, was stranger than anyone initially imagined. As more telescopes joined the observation campaign, a clearer picture began to emerge. Though clearer might be too strong a word, the object appeared to be elongated, perhaps 3 or 4 times longer than it was wide, though not as extreme as Oumuamua's needle-like shape. But the shape seemed to be changing, evolving over time in a way that solid objects simply shouldn't. It was as if 3I Atlas was slowly unraveling, like a ball of cosmic yarn being pulled apart by invisible hands. The fragmentation, if that's what it was unlike anything astronomers had seen before. When comets break apart, it's usually a violent event, triggered by tidal forces or thermal stress as they approach the Sun. The fragments typically fly apart rapidly, following slightly different trajectories. But 3I Atlas's dissolution was gentle, almost graceful. The pieces, and there seemed to be dozens of them, remained in a loose cloud, all following essentially the same path, like a school of fish swimming through the cosmic ocean. Spectroscopic observations added another layer to the mystery. The light from 3I Atlas, when broken down into its component wavelengths, showed unusual absorption lines, suggesting a composition unlike any asteroid or comet in our solar system. There were hints of complex organic molecules, long chains of carbon and hydrogen that shouldn't survive long in the harsh environment of interstellar space. There were also signs of unusual ices, not just water ice, but more exotic frozen compounds that might have formed in the extreme cold between stars. But it was when astronomers began looking at archived data that the real mystery emerged. Dr. Sarah Chen at the University of Hawaii was the first to notice it, though she initially thought it was an error in her analysis. She was searching through old observations from the Pan-STARRS telescope, looking for any previous detections of 3I Atlas that might have been missed. What she found instead were faint signals, barely above the noise threshold, that seemed to match 3I Atlas's spectral signature, but were detected weeks before the object should have been there. At first, Dr. Chen assumed she had made a mistake in her calculations, perhaps plotting the object's trajectory incorrectly. But when she double-checked, triple-checked, the anomaly remained. The signals were real, recorded in the data, time-stamped and verified. They were incredibly faint, so faint that they would never have been noticed if she hadn't been specifically looking for them, but they were there, and they were in the wrong place, or rather, the wrong time. They were detections of 3I Atlas from before 3I Atlas arrived. The scientific community's reaction was predictably skeptical. The most likely explanation was that these were false positives, random noise that happened to match 3I Atlas's signature by pure chance. Or perhaps they were signals from some other source entirely, maybe a distant galaxy or a closer but fainter object that happened to have similar spectral characteristics. Science is built on skepticism, on the principle that extraordinary claims require extraordinary evidence, and the claim that we had detected an object before it arrived was about as extraordinary as they come. But as more astronomers examined their own archived data, more of these pre-echoes were found. The European Southern Observatory reported similar signals in data from the Very Large Telescope in Chile. The Keck Observatory in Hawaii found them too, as did the Gemini Observatory. Always faint, always along the path that 3 Atlas would later travel, always with the same spectral fingerprint. The pattern was too consistent to be random noise, too widespread to be instrumental error. Dr. Marcus Webb at MIT proposed what became known as the gravitational lensing hypothesis. Perhaps, he suggested, the light from 3I Atlas was being bent by the gravitational field of some massive but invisible object, maybe a black hole or a concentration of dark matter. This bending could, in theory, cause some of the light to take a shorter path to Earth, arriving before light that travelled in a straight line. It was a stretch, requiring very specific and unlikely conditions, but it was at least physically possible within our current understanding of physics. Others proposed even more exotic explanations. Dr. Yuki Tanaka at the University of Tokyo wondered if 3I Atlas might be surrounded by some kind of exotic matter that warped space-time in its vicinity, creating what she called a temporal bubble where cause and effect could become confused. Dr. James Harrison at Oxford suggested that the object might be moving through a region of space where the vacuum itself had different properties, where the speed of light might be variable or where quantum effects could manifest on a macroscopic scale. But perhaps the most intriguing hypothesis came from Dr. Elena Vasquez at the European Space Agency. She pointed out that 3I Atlas's trajectory would take it very close to the Sun within the orbit of Mercury. At that distance, the gravitational field is strong enough to produce measurable relativistic effects. Time itself moves differently in strong gravitational fields, a phenomenon confirmed by countless experiments. Could it be, she wondered, that we were seeing some kind of relativistic effect we didn't fully understand, some way in which information about the object's future state was bleeding backward along its timeline? The debate raged quietly in academic journals and conference rooms, but publicly, most astronomers maintained a cautious stance. The data was intriguing but not conclusive. The signals were real, but their interpretation was uncertain. It was a mystery, yes, but science is full of mysteries that eventually yield to careful observation and analysis. Perhaps with more data, with better observations, the answer would become clear. Meanwhile, 3I Atlas continued its journey through our solar system, slowly fragmenting, slowly dissolving, like a message written in ice, melting before it could be fully read. By March 2023, it had broken into at least 40 distinct pieces, though broken might be the wrong word. The fragments seemed to be drifting apart gently, like seeds from a dandelion, maintaining their formation as they fell toward the Sun. The fragmentation itself became another puzzle. Analysis of the light reflected from the fragments suggested they were all roughly the same composition, but their behavior was different. Some tumbled rapidly, others hardly rotated at all. Some brightened and dimmed regularly, others showed no pattern. It was as if each fragment was following its own rules, its own physics, though they all shared the same trajectory through space. As 3I Atlas approached the Sun, astronomers prepared for what they hoped would be the best observations yet. The increased solar radiation would likely cause more outgassing, more activity, potentially revealing the object's true nature. Arrays of telescopes, both ground-based and space-based, were trained on the cosmic visitor. The Solar and Heliospheric Observatory, or SOHO, which normally watches the Sun, was ready to observe 3I Atlas's close approach. The Parker Solar Probe, humanity's closest robotic representative to our star, might even get direct measurements if the timing worked out. But as the fragments of 3I Atlas reached their closest approach to the Sun, something unexpected happened. They began to fade, not gradually as you might expect if they were simply running out of volatile materials to outgas, but suddenly, as if someone was turning off lights one by one. First one fragment disappeared from view, then another, then several at once. Within the span of just a few hours, all 40-plus fragments had vanished, leaving no trace, no debris, no explanation. The disappearance was complete and simultaneous across all wavelengths. Visible light telescopes saw nothing. Infrared detectors found no heat signature. Radio telescopes heard only silence. It was as if 3i Atlas had simply ceased to exist, or perhaps had never existed at all. But the data was undeniable. Thousands of observations over months from dozens of observatories all confirmed that something had been there and now was gone. In the aftermath of 3i Atlas's disappearance, the scientific community was left with more questions than answers. Had the object completely vaporized in the sun's heat? That seemed unlikely, as even complete vaporization should have left some detectable trace, some cloud of gas or dust. Had it been made of some exotic material that sublimated directly from solid to gas at a specific temperature, leaving nothing behind? Possible. But what material could behave that way? Or was the disappearance connected to the strange pre-echoes, another manifestation of whatever exotic physics had allowed us to detect the object before it arrived? Some theorists suggested that 3i Atlas might not have been a physical object in the traditional sense at all, but rather some kind of projection or echo from another dimension, another time, or another universe entirely. These ideas ventured far from mainstream science, but the mainstream had no better explanations to offer. Dr. Chen, who had first discovered the pre-echoes, published a paper suggesting that 3i Atlas might have been caught in what she called a causal loop, where its future state influenced its past detection. She proposed that under certain extreme conditions, perhaps involving the intense gravitational field near the Sun combined with the object's high velocity and unusual composition, information could flow backward in time, creating the pre-echoes we observed. It was a radical idea, one that challenged fundamental assumptions about the nature of reality, but it fit the data better than any other explanation. The mystery of 3i Atlas has become a kind of scientific ghost story, a tale told in observatories and university halls, a reminder that the universe is stranger than we know, perhaps stranger than we can know. Some scientists have spent years analyzing the data, looking for clues that others might have missed. Others have moved on to new mysteries, new questions, accepting that some puzzles may never be solved. But the impact of 3i Atlas goes beyond the scientific community. It has entered the public consciousness as a symbol of cosmic mystery, a reminder that we live in a universe full of wonders we don't understand. It has inspired artists and writers, philosophers and dreamers. It has become a modern myth, a story we tell ourselves about our place in the cosmos and the limits of our knowledge. As you drift towards sleep, think about 3i Atlas continuing its journey, even if we can no longer see it. Perhaps it has reformed somewhere beyond our detection, continuing its eternal voyage between the stars. Perhaps it has returned to whatever strange realm it came from, a place where time flows differently, where cause and effect dance to a different rhythm. Or perhaps it has simply dissolved into the cosmic background, its atoms and molecules spreading through space, eventually to be incorporated into new stars, new planets, new possibilities. The universe is vast and full of mysteries, and we've only just begun to explore it. Every answer we find leads to new questions. Every discovery opens new frontiers of ignorance. This isn't a failure of science, but its greatest strength, the recognition that there's always more to learn, always deeper mysteries to explore. 3i Atlas reminds us that the cosmos doesn't owe us explanations, that some things might forever remain beyond our understanding, and that's okay. The mystery itself is beautiful, the question as valuable as any answer. In the grand scheme of cosmic time, our entire civilization is barely a blink. Our whole species just a momentary arrangement of atoms that happen to become conscious and look up at the stars in wonder. We've been watching the sky for such a short time, really watching with instruments that can detect objects like 3i Atlas for just a few decades. How many other cosmic visitors have passed through our solar system unseen? How many mysteries have we missed simply because we weren't looking or didn't know how to look? Consider that 3i Atlas travelled for millions, perhaps billions of years to reach us. It crossed the vast emptiness between stars, surviving radiation and cosmic rays, the endless cold and the occasional gravitational perturbation. It carried with it information about wherever it came from, chemical signatures of its origin, physical properties shaped by conditions we may never experience. And for a brief moment, a few months in a journey of eons, it passed through our neighbourhood, close enough for us to see, to wonder about, to add to our growing catalogue of cosmic mysteries. The pre-echoes, those impossible detections of an object before it arrived, might be telling us something profound about the nature of space and time. Perhaps at the largest scales and highest energies, the universe doesn't follow the simple rules we've derived from our earthbound experiments. Perhaps information can sometimes flow in ways we don't understand, connections between events that transcend our normal notions of causality. Or perhaps we're completely wrong, and there's a simple explanation we haven't thought of yet. Something that will seem obvious in hindsight. This is how science progresses, not in a straight line but in spirals, circling back to re-examine old assumptions with new tools and new ideas. Every generation of scientists stands on the shoulders of those who came before, seeing a little farther, understanding a little more. But the horizon keeps receding. The universe keeps revealing new depths of complexity and wonder. We're like children on a beach, playing with pebbles while an entire ocean of truth stretches out before us, vast and largely unexplored. The story of 3i Atlas is also a story about us, about humanity's relentless curiosity and our need to understand our place in the cosmos. We could have ignored the anomaly, dismissed the pre-echoes as instrumental error or coincidence. We could have been content with not knowing. But that's not who we are. We're the species that looks at mysteries and says, why? We're the ones who build telescopes and particle accelerators and space probes, who dedicate our lives to understanding things that have no immediate practical value but satisfy something deep in our nature, the need to know, to explore, to understand. And perhaps that's why we're here, the universe's way of understanding itself. Through our eyes, the cosmos observes its own beauty. Through our minds, it contemplates its own mysteries. We're not separate from the universe, but part of it, temporary arrangements of matter and energy that have somehow developed the ability to wonder about our own existence. In studying objects like 3i Atlas, we're really studying ourselves, our origins, our context, our future. The fragments of 3i Atlas may be gone, dissolved in the sun's heat, or vanished through some process we don't understand, but the questions it raised remain. They join the countless other questions that drive science forward, that keep astronomers up at night, that inspire new theories and new observations. Somewhere out there, right now, other interstellar objects are passing through our solar system unseen. Some may be ordinary chunks of rock and ice, unremarkable except for their origin. Others might be as strange as 3i Atlas, or stranger still, carrying secrets we're not yet equipped to understand. As our instruments improve, as we develop new ways of looking at the universe, we'll undoubtedly discover more mysteries. Some will be solved quickly, yielding to careful analysis and clever experiments. Others will resist explanation for years or decades or centuries, and some perhaps will never be solved, remaining as permanent reminders of the limits of human knowledge, beautiful in their inscrutability. The night sky that our ancestors looked up at is the same sky you see tonight, the same stars in largely the same positions. But our understanding of what we're looking at has transformed completely. Those points of light aren't gods or spirits or holes in the celestial sphere. They're suns, perhaps with their own planets, their own mysteries, their own interstellar visitors passing through. The darkness between them isn't empty, but filled with gas and dust and dark matter, with gravitational waves and electromagnetic radiation spanning the entire spectrum from radio to gamma rays. And sometimes, just sometimes, something passes through. That darkness that doesn't fit our theories, that challenges our assumptions, that reminds us how much we still have to learn. Thyrus Atlas was one such reminder, a cosmic question mark that appeared in our sky, performed its strange dance, and vanished, leaving us with data we can't fully explain and questions we can't yet answer. But that's the beauty of it, isn't it? If we understood everything, if there were no more mysteries to solve, the universe would be a much less interesting place. The unknown isn't something to fear, but something to embrace, an invitation to learn, to grow, to expand our horizons. Every mystery is an opportunity, every question a doorway to new understanding. And even if we never solve the mystery of Three-Eye Atlas, the attempt itself has value, teaches us something, adds to the grand human endeavour of trying to understand our cosmic home. The interstellar shore, that boundary between our solar system and the vast ocean of interstellar space, isn't really a boundary at all. It's more like a gradient, a slow transition from the sun's influence to the collective influence of all the other stars in our galaxy. The heliopause, where the solar wind meets the interstellar medium, is about 120 astronomical units from the sun, roughly 18 billion kilometers. That sounds far, and it is by human standards, but it's practically next door in cosmic terms. Beyond that boundary, space isn't empty, but filled with a thin soup of gas and dust, the interstellar medium that fills the space between stars. It's incredibly sparse, millions of times less dense than the best vacuum we can create on Earth, but it's not nothing. This is the ocean through which interstellar objects like Three-Eye Atlas swim, the medium that shapes them over their long journeys. Out there, in that cosmic sea, the temperature hovers just a few degrees above absolute zero, and time seems to slow to a crawl, though of course time itself doesn't change, just the rate at which things happen. When an object like Three-Eye Atlas enters our solar system, it's like a deep-sea creature suddenly brought to the surface. The environment changes dramatically. The density of particles increases, the temperature rises, especially as it approaches the sun, and it encounters magnetic fields and radiation unlike anything in interstellar space. No wonder some of these objects behave strangely, fragmenting or outgassing, or, in the case of Three-Eye Atlas, seemingly violating our understanding of causality itself. The fact that we've only recently started detecting these interstellar visitors doesn't mean they've only recently started arriving. They've probably been passing through our solar system for billions of years, unseen and unnoticed. Current estimates suggest that there might be thousands of interstellar objects in our solar system at any given time, most too small or too distant to detect with current technology. We're surrounded by cosmic wanderers, each carrying secrets from distant corners of our galaxy. Some of these objects might be ancient, older than our solar system, formed in the early days of the galaxy when conditions were very different. Others might be relatively young, recently ejected from their home systems by gravitational interactions or stellar explosions. Each one is a time capsule, a message from another place and time, if only we knew how to read it. The chemical composition tells us about the conditions where it formed. The physical structure hints at its history, the forces and environments it has experienced. And sometimes, as with Three-Eye Atlas, they bring mysteries that challenge our fundamental understanding of physics itself. The search for interstellar objects has become a priority for many astronomers. New surveys are being designed specifically to detect these cosmic visitors. The Vera Rubin Observatory, formerly known as the Large Synoptic Survey Telescope, will scan the entire visible sky every few nights, capable of detecting objects far fainter than current surveys. It's expected to find dozens, perhaps hundreds of interstellar objects over its operational lifetime. Each one will be an opportunity to learn something new about our galaxy, about planetary formation, about the exchange of material between star systems. but finding them is just the first step. Studying them in detail requires rapid response, coordinated observations, and sometimes a bit of luck. These objects don't stay long. They sweep through our solar system on hyperbolic trajectories, here for a few months or years and then gone forever. We get one chance to observe them, to gather what data we can before they disappear back into the darkness. It's like trying to study a rare bird that lands in your garden for just a moment before flying away, never to return. The pre-echoes of 3i Atlas, those impossible early detections, have prompted some astronomers to re-examine old data from other astronomical events. Could there be other instances where we've detected something before it happened? The search has turned up a few tantalizing hints, though nothing as clear as the 3i Atlas signals. There are some supernovae that showed unusual precursor activity, gamma-ray bursts with seemingly impossible timing, fast radio bursts that don't quite fit our models. Each could be explained by conventional physics with enough assumptions and adjustments, but taken together, they hint at something we're missing, some aspect of the universe we don't yet understand. Dr. Vasquez, who proposed the relativistic explanation for the pre-echoes, has been developing a new theoretical framework she calls retrocausal astronomy. The idea is that under certain extreme conditions, particularly involving strong gravitational fields and high velocities, information can flow backward in time in limited, subtle ways. Not enough to violate causality in any dramatic sense, no grandfather paradoxes or changing the past, but enough to create detectable signals, whispers from the future that we might be able to hear if we know how to listen. It's a controversial idea, to say the least. Most physicists are skeptical, and rightly so. The foundations of physics, particularly the second law of thermodynamics and the principle of causality, seem to forbid such things. But quantum mechanics already allows for some strange temporal effects. Quantum entanglement can create correlations that seem to transcend normal space-time limitations. Some interpretations of quantum mechanics even suggest that future events can influence past probabilities, though this influence is usually too subtle to detect macroscopically. Perhaps 3i Atlas was the first clear evidence of these quantum effects manifesting on a larger scale. Maybe its unusual composition, its fragmentation, its journey through the sun's gravitational well created just the right conditions for these normally hidden aspects of reality to become visible. Or maybe we're completely wrong, chasing shadows and seeing patterns where none exist. That's the thing about frontier science. You never know whether you're on the verge of a breakthrough or walking down a dead end until you get to the end of the path. The fragmentation of 3i Atlas remains as puzzling as its pre-echoes. The gentle way it came apart, like a flower opening in slow motion, suggests something about its structure that we don't understand. Some scientists have proposed that it wasn't held together by gravity or chemical bonds like normal objects, but by some more exotic force. Perhaps it was a kind of cosmic foam, a lattice of dark matter and normal matter that could only exist in the extreme cold and low density of interstellar space. When it entered our solar system, the increased temperature and particle density caused this exotic structure to destabilize, slowly dissolving like sugar in water. Another possibility is that 3i Atlas was artificial, not in the sense of being built by aliens, though some have suggested that too, but in the sense of being a natural structure that nonetheless processed information in some way. Perhaps it was a kind of cosmic computer, its structure encoding information about its journey, and its fragmentation was actually a kind of computation, processing that information in response to the new environment of our solar system. This is highly speculative, of course, but no more so than any other explanation for what we observed. The sudden disappearance of all the fragments as they approach the sun is perhaps the strangest part of the whole mystery. Simultaneous vanishing across all wavelengths suggests something more than simple vaporization. One theory is that the fragments underwent some kind of phase transition, changing from normal matter to some exotic state we can't detect. Another is that they fell through some kind of space-time anomaly, a tiny wormhole or dimensional fold that transported them elsewhere. Or perhaps they simply became transparent to all forms of electromagnetic radiation, still there but no longer interacting with light in any way we can detect. Dr. Harrison at Oxford has suggested that the disappearance might be connected to the pre-echoes, two aspects of the same phenomenon. Perhaps 3i Atlas existed in what he calls a temporal superposition, simultaneously existing at multiple points along its timeline. The pre-echoes were glimpses of its future state, and the disappearance was when all these temporal states collapsed into one, cancelling each other out in some way we don't understand. It's a mind-bending idea, one that would require a complete reimagining of how time works on cosmic scales. But maybe we're overthinking it. Maybe there's a simple explanation we haven't considered, something that will seem obvious once someone points it out. The history of science is full of mysteries that seemed profound until they were solved, then seemed almost trivial. The retrograde motion of planets baffled astronomers for centuries until Copernicus showed it was just a consequence of Earth's own orbital motion. The mysterious canals on Mars turned out to be optical illusions. Dark matter and dark energy might one day seem equally simple once we understand what they really are. Or maybe 3i Atlas will remain a mystery forever, joining the ranks of cosmic enigmas that resist all attempts at explanation. The Tunguska event of 1908, when something exploded over Siberia with the force of 1,000 atomic bombs, leaving no crater and no clear evidence of what it was. The WOW signal detected by SETI in 1977. A powerful radio transmission from space that was never repeated or explained. The Great Attractor, a gravitational anomaly pulling galaxies toward it for reasons we don't fully understand. These mysteries remind us that the universe is under no obligation to make sense to us, that our understanding is always provisional, always subject to revision. As you continue to relax to let your mind wander through these cosmic mysteries, remember that you're part of this grand story. The atoms in your body have been on their own incredible journeys, formed in the hearts of stars, scattered by supernovae, drifting through space for millions of years before coming together to form Earth and eventually you. You're not just an observer of the universe, but a participant, a way for the cosmos to know itself, to wonder about itself, to search for meaning in the vast darkness punctuated by islands of light. The story of 3i Atlas is really a story about limits, the limits of our knowledge, our instruments, our imagination. But it's also a story about transcending those limits, about pushing beyond what we thought was possible. Every generation of humans has thought they understood the universe, only to have the next generation show them how much more there was to discover. We're no different. Our theories, our models, our understanding, they're all provisional, all subject to revision when something like 3i Atlas comes along and shows us that reality is stranger than we imagined. In the deep silence of interstellar space, where 3i Atlas spent most of its existence, time must have seemed different. With no nearby stars to mark the passage of days and years, no planets wheeling through their orbits, just the slow, almost imperceptible drift through the darkness, punctuated perhaps by the occasional distant flash of a supernova or the gradual brightening of an approaching star. For millions or billions of years, 3i Atlas travelled through this cosmic wilderness, carrying its secrets, following the subtle gravitational currents that flow between the stars. What forces shaped its journey? Every star it passed, even at distances of light years, would have tugged on it slightly, altering its trajectory by tiny amounts that accumulated over cosmic time. Perhaps it passed through stellar nurseries, regions where new stars are born from collapsing clouds of gas and dust. Perhaps it skirted the edge of old supernova remnants, shells of gas expanding outward from long-dead stars. Each encounter would have left its mark, subtle changes in velocity and direction that ultimately brought it to our solar system at just the right time for us to see it. And what are the odds of that? In the vast emptiness of space, What are the chances that this particular object would pass close enough to our particular star at just the moment in cosmic history when we had developed the technology to detect it? It's a coincidence so unlikely that it makes you wonder if there's something more to it, some deeper pattern or purpose we don't understand. Or perhaps such coincidences are inevitable given the vast number of stars and objects and the immense spans of time involved. In an infinite universe, even the most unlikely events become certainties. The pre-echoes force us to confront our assumptions about time itself. We think of time as a river flowing in one direction, from past to future, carrying everything along with it. But what if that's just our limited perspective? What if time is more like an ocean, with currents and eddies and depths we can't fathom? What if information can sometimes flow upstream, creating ripples that move backward against the current? The mathematics of physics, particularly in quantum mechanics and general relativity, don't actually require time to flow in only one direction. That's something we impose based on our experience, our observation that entropy increases, that eggs break but don't unbreak. But 3i Atlas seemed to play by different rules, or perhaps it revealed rules we didn't know existed. The pre-echoes weren't dramatic. They didn't allow us to predict the future or change the past in any meaningful way. They were subtle, barely detectable, like whispers from tomorrow that we could only hear because we happened to be listening with incredibly sensitive instruments at just the right frequencies. What other whispers might be out there, too faint for us to detect, carrying information about events that haven't happened yet? This brings us to one of the deepest questions in physics, the nature of information itself. In our everyday experience, information seems secondary to physical reality. A book contains information, but the book itself is what's real, the paper and ink. But in quantum mechanics, information takes on a more fundamental role. The quantum state of a particle is essentially information, and this information determines what physical properties we observe. Some physicists have suggested that information might be the most fundamental aspect of reality, that the universe might be, at its deepest level, a vast information processing system, computing its own future from its past according to rules we call the laws of physics. If this information-theoretic view of the universe is correct, then perhaps what we saw with 3i Atlas was a glimpse of how information really flows through the cosmos, not always forward in time, not always from cause to effect, but in more complex patterns that we're only beginning to understand. The pre-echoes might have been information about 3i Atlas's future state propagating backward through some channel we don't yet recognize, like signals through a cosmic fiber optic cable we can't see. The fragmentation pattern of 3i Atlas might hold clues we haven't deciphered yet. The way the pieces drifted apart, maintaining their formation while slowly spreading, suggests they were connected by something more than gravity. Some scientists have proposed that they were linked by quantum entanglement, that the fragments were in some sense still a single quantum system, even as they separated physically. This would be unprecedented for macroscopic objects. But 3i Atlas was unprecedented in many ways. If the fragments were quantum entangled, it might explain their simultaneous disappearance. In quantum mechanics, measuring one part of an entangled system instantly affects the other parts, regardless of the distance between them. Perhaps the intense radiation and gravitational field near the Sun acted as a kind of measurement, collapsing the quantum state of all the fragments simultaneously, causing them to vanish from our perception, though they might still exist in some form we can't detect. This is all speculation, of course, but it's informed speculation, based on real physics and real observations. The universe has surprised us before with phenomena that seemed impossible until we understood them better. Radioactivity seemed to violate conservation of energy until we discovered the equivalence of mass and energy. Quantum mechanics seemed to violate common sense until we realized common sense was based on limited experience. Perhaps 3i Atlas is showing us another limitation of our current understanding, another place where nature transcends our expectations. As we contemplate these mysteries, it's worth remembering that we're still in the early days of astronomy, really. We've only been able to detect objects like 3I Atlas for a few decades. We've only known about dark matter and dark energy for a similar span. Our most powerful telescopes are just beginning to show us the universe as it really is, in all its complexity and strangeness. What will we discover in the next decade, the next century, the next millennium? What mysteries that we can't even imagine yet are waiting out there in the darkness? The story of 3I Atlas also reminds us of the importance of keeping good records, of archiving our observations even when they seem routine. Those pre-echoes would never have been discovered if astronomers hadn't saved their data, if they hadn't built systems to store and search vast archives of observations. Somewhere in those archives might be other anomalies, other hints of phenomena we don't understand, waiting for someone to notice them, to piece together the pattern, to ask the right question. Science is often portrayed as a solitary endeavour, the lone genius making breakthrough discoveries. But the story of 3I Atlas shows how collaborative modern astronomy really is. Observers around the world work together, sharing data, coordinating observations, building on each other's work. Theorists from different fields contributed ideas, from quantum mechanics to general relativity to information theory. It was a global effort to understand a cosmic mystery, humanity working together to comprehend something beyond any one person's ability to grasp alone. And yet, for all our collaboration, all our technology, all our theories, 3I Atlas kept its deepest secrets. We observed it, we measured it, we analysed it with every tool at our disposal, and still it surprised us, confounded us, left us with more questions than answers. There's something humbling about that, something that reminds us of our place in the cosmic order. We're clever apes on a small planet. We've figured out a few things about how the universe works, but we're still children playing on the shore of an infinite ocean. The ocean metaphor is particularly apt for interstellar space. Like Earth's oceans, it seems empty from a distance, but is actually full of structure and activity. There are currents of gas and dust, waves of radiation and magnetic fields, storms of cosmic rays and stellar winds. Objects like 3I Atlas are like messages in bottles, drifting on these cosmic currents, occasionally washing up on the shores of star systems where, if anyone is watching, they might be noticed and wondered about. How many other civilizations, if they exist, have seen objects like 3I Atlas? How many have puzzled over similar mysteries, developed their own theories, come to their own conclusions? Are we part of a galaxy-wide conversation we don't even know is happening? Each civilization adding its observations and ideas to a growing understanding of cosmic phenomena? Or are we alone in our wondering, the only conscious observers in a universe of beautiful but unconscious processes? The search for extraterrestrial intelligence often focuses on radio signals, or other deliberate attempts at communication. But perhaps the real evidence of other intelligences is in the anomalies, the things that don't fit our theories, not because they're artificial necessarily, but because they might have been observed and studied by others who left some kind of mark, some subtle influence we don't recognize. This is highly speculative, of course, but 3I Atlas has taught us that the universe is capable of surprises we never imagined. As the hours pass and you drift deeper into the quiet space between waking and sleeping, let your mind wander through these possibilities. Picture 3I Atlas on its long journey, a silent voyager crossing the vast distances between stars. Imagine the pre-echoes rippling backward through time, information flowing in ways we don't understand. Think about the fragments dissolving in the sun's heat, transforming into something beyond our ability to detect, but perhaps not beyond our ability to imagine. The universe is so much larger than our everyday experience, so much stranger than our intuition suggests, but we're part of it, made from it, connected to it in ways both obvious and subtle. When we study objects like 3I Atlas, we're studying ourselves, our origins, our context, our future. We're the universe becoming aware of itself, developing the capacity for wonder, for curiosity, for understanding. It's a profound responsibility and a profound privilege. Every night as Earth turns and new stars become visible, new mysteries are potentially revealing themselves. Somewhere out there, right now, another interstellar object might be approaching our solar system, carrying its own secrets, its own challenges to our understanding. Somewhere else, a civilization might be detecting their own 3E atlas, puzzling over their own pre-echoes, wondering about the nature of time and causality just as we are. The cosmic perspective has a way of making our earthly concerns seem small, but not insignificant. We're part of something vast and ancient and ongoing, a process that started with a big bang and will continue for trillions of years into the future. Our brief moment of consciousness, our flickering awareness in the cosmic dark is precious precisely because it's so rare, so unlikely, so temporary. We're the universe's way of appreciating its own beauty, of marveling at its own mystery. 3I Atlas has come and gone, but its legacy remains in the questions it raised, the assumptions it challenged, the wonder it inspired. It reminded us that we don't have all the answers, that the universe is still capable of surprising us, that there's so much more to discover. It was a gift, really, a cosmic koan that has no easy answer, that forces us to think deeper, to imagine more boldly, to remain humble in the face of cosmic mystery. As you prepare to cross the threshold into sleep, carry with you this sense of wonder, this connection to the cosmos. You're not separate from the universe, but woven into it. Your atoms forged in stars, your consciousness emerging from the same physical laws that govern the motion of galaxies and the behavior of quantum particles. In your dreams tonight, you might travel to distant stars, might solve mysteries that elude our waking minds, might experience time in ways that 3I Atlas would understand. The gentle darkness of space, punctuated by the light of distant stars, is not so different from the darkness behind your closed eyelids, punctuated by the fleeting images of dreams. Both are realms of possibility, of mystery, of beauty that doesn't require understanding to be appreciated. 3I Atlas travelled through that darkness for eons, and now you travel through your own darkness toward rest, toward dreams, toward tomorrow. The universe continues its patient unfolding, galaxies spinning, stars burning, planets orbiting, and somewhere in all that cosmic activity, on one small planet, you rest, you dream, you become part of the great mystery yourself. The questions raised by 3I Atlas don't need immediate answers. They can simply be held, like beautiful stones collected on a beach, turned over in the mind, appreciated for their mystery as much as for any solution they might eventually yield. Tomorrow the sun will rise, Earth will continue its orbit, and astronomers will continue their watch, looking for the next cosmic visitor, the next mystery, the next reminder of how much we have yet to learn. But tonight, in this moment, you can rest in the knowledge that you're part of something magnificent, something that includes both the familiar comfort of your bed and the strange journey of 3I Atlas, both the known and the unknown, both the questions and the quiet spaces between them where wonder lives. The echoes arrive before the voice, like hearing thunder from a storm that hasn't formed yet, like seeing ripples on a pond before the stone has been thrown. This is the heart of our mystery, the impossible observation that has kept scientists awake at night, staring at data that shouldn't exist, running calculations that don't make sense, questioning everything they thought they knew about how information travels through the universe. When we talk about detecting 3I Atlas before it arrived, we're not speaking metaphorically or poetically, though it certainly sounds like poetry, like something from a dream or a science fiction story. We're talking about real data, real observations, recorded by multiple instruments at different locations, all showing the same impossible thing, signatures of an object appearing along a path it had not yet travelled. To understand how extraordinary this is, we need to think about how we normally detect objects in space. Light, whether visible or in other wavelengths like infrared or radio, travels at a finite speed, about 300,000 kilometers per second. When we see something, we're seeing light that left that object some time ago, the delay depending on the distance. When you look at the moon, you're seeing it as it was about 1.3 seconds ago. When you look at the sun, you're seeing it as it was about 8 minutes ago. When you look at the nearest star beyond our sun, Proxima Centauri, you're seeing it as it was about 4.2 years ago. This is fundamental to astronomy, to physics, to our understanding of causality itself. Cause precedes effect. The stone falls into the pond, then we see the ripples. The star explodes, then we see the light. The object arrives, then we detect it. But 3 Atlas seem to violate this fundamental principle. The first pre-echo was discovered by Dr. Sarah Chen, almost by accident. She was searching through archived data from the Pan-STARRS telescope, looking for any previous detections of 3I Atlas that might have been missed in the initial automated searches. Pan-STARRS, the Panoramic Survey Telescope and Rapid Response System, takes images of large swathes of the sky every night, looking for moving objects that might be asteroids, comets, or other things of interest. The data is processed automatically, but not everything gets caught in the first pass. Sometimes, going back through the data with the knowledge of what to look for reveals things that were missed. Dr. Chen expected to find, at best, a few faint detections of 3I Atlas from a few days before its official discovery, points of light that were too faint or moving too slowly to trigger the automated detection systems. What she found instead was something that made her question her own calculations, her own sanity even. There were faint signals, barely above the noise level, that matched 3I Atlas's spectral signature, its unique fingerprint of reflected and emitted light. But these signals were in the wrong place, or rather, the wrong time. They were detected weeks before 3I Atlas should have been there, in positions along its future path. At first she assumed she'd made an error. Perhaps she'd miscalculated the object's trajectory, extrapolating backward incorrectly. She checked her math once, twice, a dozen times. She had colleagues check it. The calculations were correct. The signals were real, recorded in the data with precise timestamps. They were faint, so faint that they would never have been noticed if she hadn't been specifically looking for them with sophisticated filtering techniques. But they were there, like ghostly footprints marking a path that hadn't been walked yet. The scientific method demands skepticism, especially when faced with observations that challenge fundamental assumptions. Dr. Takasu Chien and her colleagues considered every possible conventional explanation. Could these be signals from a different object that happened to have similar spectral characteristics? Unlikely, given the precise match and the fact that the signals appeared exactly along 3I Atlas's future path. Could they be some kind of instrumental artifact? False signals created by the telescope or the data processing? Possible. But then why did they appear in data from multiple telescopes? Different instruments with different designs and different data processing pipelines. As word of the discovery spread through the astronomical community, other researchers began examining their own archived data. The European Southern Observatory found similar pre-echoes in data from the Very Large Telescope in Chile. The Keck Observatory in Hawaii found them too. The Gemini Observatory, the Subaru Telescope. Even some amateur astronomers with sophisticated equipment found hints of these signals in their data. Always faint, always along the exact path that 3I Atlas would later travel, always with the same spectral signature. The pattern was too consistent to be coincidence, too widespread to be error. Something real was happening, something that didn't fit our understanding of physics. The astronomical community found itself in the uncomfortable position of having observations they couldn't explain, data that suggested the impossible. It was like finding a fossil in the wrong geological layer, a star moving faster than light, a perpetual motion machine that actually worked. It shouldn't be possible, but there it was, recorded in terabytes of data from some of the most sophisticated instruments ever built. Dr. Marcus Webb at MIT was one of the first to propose a physical explanation that didn't require abandoning causality entirely. His gravitational lensing hypothesis suggested that the light from 3I Atlas was being bent by some massive but invisible object, perhaps a black hole or a concentration of dark matter. Gravitational lensing is a well-established phenomenon, predicted by Einstein's general relativity and observed countless times. Massive objects bend space-time, and light follows the curves of space-time, so light passing near a massive object can be deflected, focused, or even split into multiple paths. In most cases of gravitational lensing, we see multiple images of the same object, or a distorted arc-like image called an Einstein ring. But Dr. Webb proposed something more subtle. What if there was a massive object positioned just right, so that some of the light from 3I Atlas took a curved path that was actually shorter than the straight-line path? In the curved space-time around a massive object, the shortest distance between 2 points isn't always a straight line. It's possible, in principle, for light taking a curved path to arrive before light travelling in what appears to be a straight line. The problem with this hypothesis was that it required very specific conditions. The massive object would have to be positioned perfectly, have just the right mass distribution, and be completely invisible to our telescopes. We should be able to detect its gravitational influence on nearby stars or its effect on the cosmic microwave background radiation. But searches for such an object came up empty. If it was there, it was hiding very well, which raised its own set of questions. Dark matter doesn't interact with light, but it does have gravitational effects we can measure. This hypothetical object would have to be something else, something we've never encountered before. Dr. Yuki Tanaka at the University of Tokyo took a different approach. She suggested that 3I Atlas might be surrounded by some kind of exotic matter that warped space-time in its immediate vicinity. This wasn't a gravitational effect in the traditional sense, but something more exotic, perhaps related to quantum mechanics or some undiscovered property of matter. She called it a temporal bubble, a region where the normal rules of causality were slightly relaxed, where information could leak from future to past in limited ways. The idea wasn't completely without precedent. In quantum mechanics, there are phenomena that seem to violate our intuitive understanding of time and causality. Quantum entanglement can create correlations between particles that seem to transcend space-time. Some interpretations of quantum mechanics suggest that future measurements can influence past quantum states, though this influence is usually too subtle to detect macroscopically. Perhaps 3I Atlas, with its unusual composition and behavior, was somehow amplifying these quantum effects, making them visible on a scale we could observe. Dr. Tanaka's hypothesis led to a flurry of theoretical work. Physicists dusted off old papers about closed time-like curves, regions of space-time where time loops back on itself. They revisited theories about tachyons, hypothetical particles that travel faster than light and move backward in time. They explored the mathematics of retrocausality, the idea that future events can influence past events in ways that don't create paradoxes. The equations were complex, the implications mind-bending, but they offered at least the possibility of explaining what we were seeing. Meanwhile, observational astronomers continued to gather data on 3I Atlas itself, hoping that understanding the object better might explain the pre-echoes. The fragmentation pattern was particularly interesting. As 3I Atlas approached the Sun, it didn't break apart violently like comets sometimes do. Instead, it seemed to gently dissociate, like a loosely bound cluster slowly spreading out. The fragments maintained their relative positions for weeks, drifting apart so slowly that it was almost imperceptible. Spectroscopic analysis of the fragments revealed something even stranger. Each fragment had a slightly different spectrum, as if they were made of different materials or were at different temperatures. But the differences followed a pattern, a mathematical progression that some researchers compared to a musical scale or a Fibonacci sequence. It was as if the object had been designed to fragment in this specific way, each piece carrying a different part of some cosmic message we couldn't decode. Dr. Elena Vasquez at the European Space Agency focused on the relativistic aspects of the problem. As 3I Atlas approached the Sun, it entered a region where gravitational time dilation becomes measurable. Time literally runs slower in stronger gravitational fields, an effect confirmed by countless experiments and essential for the accurate operation of GPS satellites. Dr. Bia Vasquez wondered if the combination of 3I Atlas's high velocity and the Sun's gravitational field might create conditions where information could propagate in unexpected ways. She developed a model based on what she called gravitational quantum channels, pathways through space-time where quantum information could travel faster than light without violating relativity. The key insight was that information and energy are not the same thing. While energy is limited by the speed of light, quantum information might, under very specific conditions, find shortcuts through the quantum foam that underlies space-time at the smallest scales. The model was elegant and mathematically consistent, but it made predictions that were difficult to test. It suggested that the pre-echoes should be stronger near massive objects and weaker in the relatively empty space between stars. It predicted that certain frequencies of light should show stronger pre-echoes than others, depending on the local curvature of space-time. Some of these predictions matched the observations, others didn't, and some couldn't be tested with existing technology. As 3I Atlas continued its approach to the Sun, astronomers prepared for what they hoped would be definitive observations. The Solar and Heliospheric Observatory, SOHO, was positioned to watch the object's close approach. The Parker Solar Probe, humanity's closest robotic emissary to our star, might even be able to make direct measurements. Ground-based telescopes around the world coordinated their observations, ensuring continuous coverage as Earth rotated. The pre-echoes meanwhile grew stronger as 3I Atlas approached. What had been barely detectable whispers became clearer signals, though still faint by normal astronomical standards. It was as if the object was shouting backward in time, and the closer it got to the Sun, the louder its temporal voice became. Some researchers reported detecting pre-echoes from events that hadn't happened yet, fluctuations in brightness that would occur days in the future, changes in the object's spectrum that were yet to come. This raised profound questions about free will and determinism. If we could detect an object's future state, was that future fixed? Could we change it? Some astronomers proposed experiments to test this, planning observations that would depend on the pre-echoes themselves. If the pre-echoes showed the object brightening, they would observe it with one set of instruments. If they showed it dimming, they would use different instruments. Would the pre-echoes change based on these decisions? Would paradoxes emerge? But before these experiments could be conducted, 3I Atlas began its final approach to the Sun, and things became even stranger. The fragments, which had been slowly drifting apart for weeks, suddenly began to show coordinated behavior. They pulsed in unison, brightening and dimming together despite being separated by thousands of kilometers. The pattern of pulsing was complex but clearly non-random, following a mathematical sequence that some compared to prime numbers, others to the golden ratio. Dr. James Harrison at Oxford suggested that the fragments might be quantum entangled, maintaining instantaneous correlation despite their physical separation. Quantum entanglement had been demonstrated many times with subatomic particles, but never with macroscopic objects, especially not objects hundreds of meters across separated by vast distances. If the fragments were entangled, it would represent a completely new phenomenon, something that could revolutionize our understanding of quantum mechanics and its role in the macroscopic world. The pulsing patterns seemed to accelerate as the fragments approached perihelion, their closest approach to the Sun. The pre-echoes became chaotic, showing multiple possible futures simultaneously, as if reality itself was becoming uncertain. Some telescopes detected the fragments in positions they wouldn't reach for hours, others saw them where they had been days ago. It was as if time around 3I Atlas had become fluid, non-linear, more like a probability cloud than a definite sequence of events, and then, as the fragments reached their closest approach to the sun, they vanished. Not gradually, not one by one, but all at once, simultaneously across all wavelengths. One moment they were there, pulsing in their mysterious pattern, casting their temporal shadows both forward and backward, and the next moment they were gone. No debris, no gas cloud, no trace of their existence except for the data recorded over the previous months, and the pre-echoes that lingered for a few more hours before they too faded away. The disappearance was so complete, so sudden, that some astronomers initially thought there had been an instrumental failure, but checks of the equipment showed everything was functioning normally. The sun was still there, other celestial objects were still visible, only 3i Atlas was gone. It was as if it had never existed, except we had months of data proving that it had. In the aftermath, the scientific community was left to grapple with observations that challenged some of the most fundamental assumptions in physics. The pre-echoes were real, documented by multiple independent observations. The fragmentation pattern, the synchronized pulsing, the sudden disappearance, all of it was recorded, analyzed, and confirmed. But what did it mean? How could it be explained without abandoning the principles that underlie our understanding of the universe? Some physicists suggested that we had witnessed a natural phenomenon that revealed new physics, the way radioactivity revealed the existence of nuclear forces, or the way the photoelectric effect revealed the quantum nature of light. Perhaps there were additional dimensions of space-time that only became apparent under extreme conditions. Perhaps information could travel through these dimensions in ways that appear to violate causality in our limited three-dimensional perspective. Others proposed more radical ideas. Maybe consciousness plays a role in collapsing quantum possibilities into definite realities, and 3i Atlas existed in a superposition of states until observed closely enough. Maybe the universe is more like a simulation or a hologram than we realize, and 3i Atlas was a glitch in the system, a rendering error that revealed the computational nature of reality. These ideas ventured far from mainstream science, but mainstream science had no better explanations to offer. Dr. Chen, who had discovered the first pre-echoes, published a comprehensive analysis of all the data, looking for patterns that might have been missed. She found that the strength of the pre-echoes correlated with solar activity, stronger during solar flares and weaker during quiet periods. This suggested a connection between the sun's magnetic field and whatever mechanism allowed the pre-echoes to exist. She also found that the pre-echoes were polarized in a specific way. Their light waves aligned in a pattern that spiraled like a corkscrew, changing orientation as 3i Atlas moved through space. This polarization pattern was particularly intriguing because it seemed to encode information. When analyzed mathematically, it produced a series of numbers that some researchers recognized as fundamental physical constants: the speed of light, Planck's constant, the fine structure constant. Others saw different patterns, mathematical relationships that appeared in everything from quantum mechanics to cosmology. It was as if 3i Atlas was trying to tell us something, to teach us something about the nature of reality, but we couldn't quite understand the lesson. The search for similar phenomena in other astronomical observations intensified. If 3i Atlas showed pre-echoes, might other objects do the same under the right conditions? Researchers re-examined data from supernovae, looking for precursor signals that might have been dismissed as noise. They studied fast radio bursts, mysterious signals from deep space that last only milliseconds, wondering if some of them might be temporal echoes rather than physical emissions. They even looked at data from gravitational wave detectors, searching for ripples in space-time that preceded their apparent causes. A few tantalizing candidates emerged. A supernova in a distant galaxy showed unusual fluctuations in its light curve weeks before the explosion, fluctuations that seemed to predict the exact pattern of the subsequent blast. A fast radio burst detected by the Arecibo telescope before its collapse appeared to repeat, but with the repetitions occurring before the original signal, as if echoing backward in time. These observations were even more ambiguous than the Three-Eye Atlas pre-echoes, but they suggested that retrocausal phenomena might be more common than we thought, just usually too subtle to detect. The implications extended beyond astronomy and physics into philosophy and even theology. If effects could precede causes, what did that mean for free will? If the future could influence the past, was time travel possible? Different cultures and religions had different perspectives on these questions. Some saw validation of ancient beliefs about the cyclical nature of time or the interconnectedness of all things. Others saw challenges to doctrines about divine providence or human agency. Scientists, for the most part, tried to stay focused on the data and what it could tell us about the physical world, but it was impossible to completely avoid the deeper questions. If Three-Eye Atlas had truly demonstrated retrocausality, it would rank among the most important discoveries in the history of science, on par with evolution or quantum mechanics in terms of its impact on our worldview. It would mean that reality is far stranger and more wonderful than we imagined, that the universe operates according to principles we're only beginning to glimpse. As months passed and the immediate excitement faded, researchers settled into the long, careful work of analysis and theory building. The data from Three-Eye Atlas was shared freely, posted online for anyone to examine. Citizen scientists joined professional astronomers in looking for patterns, testing hypotheses, trying to solve the mystery. It became a global puzzle, a cosmic riddle that anyone with a computer and curiosity could help solve. Some progress was made. A team at Caltech developed a mathematical framework that could explain the pre-echoes using a modification of quantum field theory. A group at Cambridge proposed experiments using entangled particles that might recreate the effect on a smaller scale. Researchers at the Perimeter Institute suggested that Three-Eye Atlas might have been a temporal artifact, an object that existed primarily in time rather than space, only becoming visible to us when its timeline intersected with ours. But for every question answered, new questions emerged. Why did Three-Eye Atlas fragment the way it did? What determined the pattern of the synchronized pulsing? Why did it disappear so completely at perihelion? Was its arrival in our solar system random, or was there some purpose, some intention behind it? These questions led to others, deeper and more troubling. Are we alone in the universe? Is reality what we think it is? Are we capable of understanding the true nature of existence? The pre-echoes of Three-Eye Atlas had shown us something extraordinary, a glimpse of physics beyond our current understanding. They suggested that time might not be the simple, linear progression we experience, that causality might be more flexible than we believed, that information might flow in ways we never imagined. But glimpses are not understanding, and suggestions are not proof. The mystery remained, beautiful and frustrating in equal measure. As you continue to drift towards sleep, consider the possibility that Three-Eye Atlas is still out there somewhere, or somewhen. Perhaps it didn't disappear but simply moved outside our ability to perceive it, shifting into a different dimension or a different time. Perhaps it's travelling backward now, moving from future to past, and what we saw was the moment when its timeline briefly aligned with ours. Perhaps it will appear again someday, or perhaps it already has, in the distant past or the far future, leaving pre-echoes and post-echoes throughout time like ripples spreading from a stone thrown into the temporal stream. The universe is vast in space, but it's also vast in time, stretching from the Big Bang to the far future when the last stars burn out and darkness finally claims everything. In that immense temporal expanse, Three Atlas's few months in our solar system were less than a blink, a fleeting moment of intersection between its journey and our observation. But in that moment, it showed us wonders we're still trying to understand, mysteries we're still trying to solve. Time itself becomes strange when you think about it deeply enough. We experience it as a flow from past to future, but physics describes it as a dimension, like the 3 dimensions of space. In the equations of relativity and quantum mechanics, time has no preferred direction. The laws of physics work equally well running forward or backward. It's only the second law of thermodynamics, the increase of entropy, that gives time its apparent arrow, and even that might not be as absolute as we once thought. Perhaps 3i Atlas came from a region of space where entropy flows differently, where time's arrow points in another direction or multiple directions at once. Perhaps it was a messenger from a part of the universe where the Big Bang hasn't happened yet, or where it's happening in reverse. These ideas sound like fantasy, but they're grounded in real physics, real mathematics, real possibilities that emerge from our best theories about how reality works. The pre-echoes force us to confront the possibility that our perception of time is just that, a perception, not an absolute truth. Just as we once thought the Earth was flat because that's how it appears to our limited senses, we think time flows in one direction because that's how we experience it. But the universe is under no obligation to conform to our perceptions or our intuitions. It operates according to its own rules we're still trying to discover. In the quiet of the night, with the stars wheeling overhead in their ancient patterns, it's easier to feel the mystery, to sense the vast unknown that surrounds our small island of knowledge. 3 Atlas was a visitor from that unknown, a temporary bridge between what we understand and what we don't. Its pre-echoes were whispers from beyond the edge of our comprehension, hints that reality is far more magnificent and strange than we've imagined. As you settle deeper into rest, your breathing slowing, your thoughts becoming dreamlike and fluid, you're entering a state where time becomes elastic, where past and future can mix in the landscape of dreams. In this state, you might understand 3 Atlas better than any waking scientist, might glimpse the truth that our conscious minds can't quite grasp. Dreams have their own physics, their own causality, their own relationship with time. Perhaps that's why 3i Atlas seems more like a dream than a scientific observation, because it showed us that the universe itself might be more dreamlike than we thought. The story of the pre-echoes isn't finished. Somewhere, astronomers are still analysing the data, still developing theories, still watching the sky for other objects that might show similar behaviour. The mystery of 3i Atlas has become part of the great tapestry of unsolved problems in science, joining dark matter, dark energy, the nature of consciousness, and the origin of life as questions that drive us forward, that keep us searching, wondering, discovering. And perhaps that's the real gift of 3i Atlas, not the answers it might eventually provide, but the questions it has raised, the wonder it has inspired, the reminder that we live in a universe full of surprises. Every solved mystery reveals new mysteries. Every answered question leads to deeper questions. The pre-echoes of 3i Atlas echoed not just through space and time, but through human consciousness, rippling outward in waves of curiosity and awe that will continue long after the object itself has faded from memory. Time, as 3i Atlas seemed to demonstrate, is not a simple river flowing from past to future. It's something far more complex, far more beautiful, far more mysterious. It's an ocean with currents we don't understand, depths we've never explored, shores we've never seen. And sometimes, rarely, something washes up from those depths that shows us just how little we know, just how much there is still to discover. The ripples on the river of time spread outward from every event, every observation, every moment of wonder. 3 Atlas created ripples that moved both forward and backward, upstream and downstream, creating interference patterns in the flow of causality that we're still trying to map. These ripples intersect with others from other events, other mysteries, other moments of discovery, creating a complex pattern that is the history and future of human understanding. Think of time not as a river, but as a vast ocean, with currents and tides, storms and calms, shallows and depths. In most places, the water flows predictably, following patterns we've learned to recognize and navigate. But there are also strange regions where the water behaves differently, where whirlpools form, where currents reverse, where the normal rules don't quite apply. The 3I Atlas showed us one of these strange regions, gave us a glimpse of the ocean's hidden complexity. In this ocean of time, past, present, and future are not separate territories, but different depths of the same water. On the surface, where we live our daily lives, they seem distinct, separated by the waves of causality. But in the depths, they merge and mix in ways we're only beginning to understand. Information can flow through these depths, carried by currents we can't see, emerging in unexpected places and times, like messages in bottles from distant shores. The metaphor of the ocean is particularly appropriate because, like Earth's oceans, the ocean of time is mostly unexplored. We've mapped the surface, charted the obvious currents, but the depths remain mysterious. We know more about the surface of Mars than we do about the deep ocean trenches of Earth, and we know more about the present moment than we do about the deep structure of time itself. 3I Atlas was like a deep-sea creature briefly surfacing, giving us a glimpse of the strange life that exists in the temporal depths. Consider how gravitational lensing works, how massive objects bend light, creating multiple images or distorted views of distant galaxies. Now imagine temporal lensing, where massive events or exotic objects bend time itself, creating multiple moments or distorted sequences of causality. The pre-echoes of 3I Atlas might have been temporal mirages, the same event seen from different temporal angles, arriving at different times depending on the path they took through the curved space-time around massive objects. This isn't just speculation. General relativity tells us that space and time are aspects of the same thing, space-time, and that massive objects curve space-time. We usually think about this in terms of spatial curvature, how planets orbit stars or how light bends around galaxies, but temporal curvature is just as real, just usually too subtle to notice. Near a black hole, time dilation becomes extreme. At the event horizon, time essentially stops from an outside perspective. Perhaps 3I Atlas passed through regions of subtle but significant temporal curvature, regions where time itself was lensed. Dr. Vasquez's work on gravitational quantum channels has evolved into a broader theory she calls temporal topology. Just as the topology of space, its shape and connectivity, affects how objects move through it, the topology of time might affect how information propagates. In regions where space-time is strongly curved, or where quantum effects become significant, the topology of time might become complex, with loops, branches, and shortcuts that allow information to take paths that seem to violate causality from our limited perspective. The mathematics of temporal topology is beautiful but challenging, involving concepts from differential geometry, quantum field theory, and information theory. It suggests that the universe might be riddled with temporal wormholes, microscopic shortcuts through time that normally have no observable effects, but might become significant under extreme conditions. 3I Atlas, with its unusual composition and behavior, might have been able to interact with these temporal wormholes, sending information through them like signals through cosmic fiber optic cables. This theory makes testable predictions. It suggests that pre-echoes should be more common near massive objects like black holes or neutron stars. It predicts that certain types of particles or waves might be more susceptible to temporal effects than others. It even suggests that we might be able to create artificial pre-echoes using precisely configured gravitational fields or quantum systems. Several experiments are being planned to test these predictions, though the technical challenges are formidable. Meanwhile, the analysis of 3I Atlas's fragmentation pattern has revealed even more mysteries. The fragments didn't just drift apart randomly. They followed trajectories that seem to minimize something called the action, a quantity in physics that nature tends to minimize. It's as if the fragments knew where they needed to go and took the most efficient paths to get there. This suggests a level of coordination or pre-planning that seems impossible for a natural object, leading some to reconsider whether 3I Atlas might have been artificial after all. But artificial doesn't necessarily mean alien. Some theorists have proposed that 3I Atlas might have been a natural quantum computer, a structure that evolved in the extreme conditions of interstellar space to process information using quantum mechanics. Just as biological evolution produced brains that can process information, cosmic evolution might produce structures that can perform quantum computations on a macroscopic scale. The fragmentation might have been a computational process, solving some cosmic equation we don't understand. The synchronized pulsing of the fragments supports this idea. The pattern, when analyzed using techniques from quantum information theory, shows characteristics similar to quantum error correction codes. These are mathematical structures used in quantum computing to protect information from decoherence, the process by which quantum systems lose their quantum properties and become classical. If the fragments were performing quantum computations, the pulsing might have been a way of maintaining quantum coherence despite the disruptive environment near the Sun. Dr. Harrison's latest work suggests an even more radical possibility. He proposes that 3i Atlas might have been what he calls a temporal computer, a device that performs computations not through space but through time. Instead of moving information between different spatial locations like a conventional computer, a temporal computer would move information between different moments. The pre-echoes might have been the output of computations that use future data as input, creating what he calls retrocausal algorithms. This idea sounds like pure science fiction, but it's based on solid theoretical foundations. Quantum mechanics already allows for certain types of retrocausal effects, and some interpretations of quantum mechanics explicitly include retrocausality. The challenge is scaling these effects up from the quantum to the classical level, from individual particles to macroscopic objects. 3i Atlas might have been the first observed example of macroscopic retrocausality, a glimpse of physics that we're only beginning to understand. The implications for computing and information theory are staggering. If temporal computers are possible, they could solve problems that are intractable for conventional computers, even quantum computers. They could predict future events by literally accessing future information. They could optimize processes by trying multiple approaches simultaneously across different timelines. They could even, in principle, send messages to the past, though presumably with limitations that prevent paradoxes. But perhaps we're overthinking it. Perhaps 3i Atlas was exactly what it appeared to be, a chunk of exotic matter from interstellar space that happened to interact with space-time in unusual ways. The pre-echoes, the fragmentation, the disappearance, they might all be natural consequences of physics we don't yet understand, no more designed or intentional than the aurora borealis or the rings of Saturn. Nature is capable of creating beauty and mystery without purpose or intention. Yet the pattern of the pre-echoes haunts us. They weren't random. They followed 3 Atlas's trajectory precisely, appearing exactly where and when the object would later be, or rather, where and when it would be in what we call the future. This precision suggests something more than chance, some deep connection between the object and the structure of space-time itself. It's as if 3i Atlas was so massive or so exotic that it created ripples in time that propagated both forward and backward from its presence. Think about how a boat moving through water creates a wake that spreads outward in a V-shape behind it. Now imagine a boat moving through time, creating a temporal wake that spreads both forward and backward. The pre-echoes might have been the backward spreading part of this wake, disturbances in the fabric of time caused by 3i Atlas's passage. From our perspective, embedded in the flow of time, we saw these disturbances as impossible precursors, but from a higher dimensional perspective, they might be as natural as the wake behind a boat. This temporal wake hypothesis, proposed by a team at the Princeton Institute for Advanced Study, has interesting implications. It suggests that all objects create temporal wakes, but usually they're too faint to detect. Only objects with extreme properties, like 3i Atlas's unusual composition or trajectory, create wakes strong enough to observe. It also suggests that we might be surrounded by temporal wakes from events both past and future, an invisible turbulence in time that might subtly influence everything from quantum processes to human consciousness. Some researchers have even suggested that dark matter and dark energy might be related to these temporal effects. What if dark matter isn't matter at all, but the gravitational influence of objects in our past or future, their temporal wakes creating the extra gravity we observe? What if dark energy, the mysterious force accelerating the expansion of the universe, is actually the influence of the universe's future state on its present, a kind of cosmic pre-echo on the largest possible scale? These ideas are highly speculative, far from proven, but they illustrate how 3i Atlas has opened new avenues of thought, new ways of looking at old mysteries. Sometimes in science, the most important discoveries aren't answers, but better questions. And 3i Atlas has given us questions that might take generations to answer. As the night deepens and your consciousness drifts closer to sleep, the boundaries between what's known and unknown, possible and impossible, begin to blur. In this liminal state, the mystery of 3i Atlas seems less strange, more like a natural part of a universe that's far more fluid and interconnected than our waking minds usually perceive. Perhaps dreams are glimpses of this deeper reality, where time is negotiable, where causality is flexible, where the impossible becomes possible. The fragments of 3i Atlas, in their final moments before disappearing, pulsed in a pattern that some researchers have compared to brainwaves during REM sleep. This might be coincidence, but it's a poetic one. As you enter your own REM sleep tonight, your brain will generate patterns of electrical activity, not unlike the pulsing of those cosmic fragments. In dreams, you might travel through time, experience events out of sequence, know things before they happen. In dreams, you might understand 3i Atlas in ways that elude our waking analysis. The universe is patient with our ignorance, generous with its mysteries. It took us thousands of years to understand that the Earth orbits the Sun, centuries to discover the nature of light, decades to unravel the structure of atoms. How long will it take us to understand 3i Atlas and the pre-echoes it left behind? Perhaps years, perhaps centuries, perhaps never. But the journey toward understanding is as valuable as the destination, maybe more so. Every scientist working on the 3i Atlas mystery, every observation, every calculation, every wild hypothesis and careful analysis adds to our collective understanding of the universe. Even the failures, the theories that don't work out, the observations that don't fit, teach us something. Science is a collaborative enterprise extending across generations, each building on the work of those who came before, laying foundations for those who will come after. Somewhere tonight, a graduate student might be staring at data from 3i Atlas, noticing a pattern everyone else missed. Somewhere, a theorist might be scribbling equations that will revolutionize our understanding of time. Somewhere, an engineer might be designing an instrument that will detect the next 3i Atlas before it arrives, or perhaps after it leaves, or perhaps both simultaneously. The mystery continues, the search continues, the wonder continues. The pre-echoes of 3i Atlas have become echoes in human consciousness, rippling through our scientific literature, our philosophical discussions, our dreams and imaginations. They've reminded us that we're still at the beginning of our journey of understanding, that the universe still has surprises in store, that reality is far stranger and more beautiful than we've imagined. They've given us a gift more valuable than answers. They've given us wonder. As you drift towards sleep, carried on the gentle currents of drowsiness, think of yourself as floating on that ocean of time we talked about. The surface is calm, the familiar progression from evening to night to morning. But beneath you, in the depths, currents flow in all directions, carrying information and influence between past and future, between what was and what will be. 3i Atlas dove through these depths, briefly surfacing in our present before disappearing again, leaving only ripples to mark its passage. Those ripples continue to spread, backward into the past as papers are written about historical observations that might have been pre-echoes, forward into the future as new theories and experiments are planned. The ripples intersect with other ripples from other cosmic events, creating an interference pattern that is the texture of reality itself. We're part of this pattern, our observations and theories adding our own ripples to the mix. In the mathematics of waves, when ripples meet, they can amplify each other or cancel each other out, creating regions of intensity and regions of calm. Perhaps the pre-echoes of Three-Eye Atlas occurred at one of these interference points, where ripples from multiple events combine to create something observable. Perhaps there are other such points throughout space-time, places where the veil between past and future becomes thin, where information can leak through in ways that seem impossible. The search for these points has become a new field of astronomy, temporal astronomy, using sophisticated algorithms to analyze vast amounts of data for signs of retrocausal effects. Machine learning systems are being trained to recognize the subtle signatures of pre-echoes, to distinguish them from noise and conventional signals. Radio telescopes are being synchronized to create a planet-wide temporal observatory capable of detecting the faintest whispers from tomorrow. But technology alone won't solve the mystery of Three-Eye Atlas. We need new ways of thinking, new conceptual frameworks that can accommodate both causality and retrocausality, both the arrow of time and the possibility of temporal loops. We need to expand our imagination while maintaining scientific rigor, to be open to the impossible while demanding evidence for the extraordinary. It's a delicate balance, one that science has always had to maintain, but never more so than when confronting something like Three-Eye Atlas. The object itself, or its fragments, or whatever they became when they disappeared near the sun, might still exist in some form we can't detect. Perhaps they've shifted into a different dimension, one of the extra dimensions predicted by string theory. Perhaps they've become dark matter, invisible to our instruments but still gravitationally present. Perhaps they've travelled to a different time, existing in our past or future, but not our present. Or perhaps they've truly ceased to exist, their purpose fulfilled, their message delivered, even if we don't yet understand what that message was. The message might not be in words or equations, but in the mere fact of Three-Eye Atlas's existence and behaviour. It showed us that our understanding of physics is incomplete, that nature still has surprises in store. It demonstrated that objects from interstellar space can have properties we never imagined. It proved that the universe is stranger than we knew, and probably stranger than we can know. Sometimes the message is the mystery itself. As sleep approaches, as your thoughts become less linear and more associative, you might find yourself thinking about Three-Eye Atlas in new ways. Not as a scientific problem to be solved, but as a cosmic koan to be contemplated. What is the sound of one hand clapping? What is the echo that comes before the voice? These questions don't have answers in the conventional sense, but contemplating them can lead to insights that transcend ordinary understanding. The pre-echoes of Three Atlas might be teaching us that our ordinary understanding of time is just a special case, valid in the limited realm of human experience but not universal. Just as Newtonian physics is a special case of relativity, valid at low speeds and weak gravitational fields, our perception of causality might be a special case of a more general principle that allows for retrocausal effects under extreme conditions. This doesn't mean that everything we know is wrong, just incomplete. The sun will still rise tomorrow, or rather, Earth will continue to rotate and the sun will appear to rise. Causes will still precede effects in almost all circumstances we encounter. Time will continue to flow from past to future in our daily experience. But now we know that there are exceptions, rare and exotic circumstances where these rules bend or break, where the impossible becomes possible. The universe is like a vast library where we've only read a few books, only explored a few shelves. Three Atlas showed us that there are entire sections we didn't know existed, filled with books written in languages we haven't learned to read. The pre-echoes were like finding a book that reads itself backward, starting with the ending and proceeding to the beginning. It doesn't make sense according to our usual way of reading, but that doesn't mean it doesn't make sense at all. Every great discovery in science has required us to abandon some cherished assumption, to expand our conception of what's possible. The discovery that Earth orbits the Sun required abandoning the assumption that we're at the center of the universe. The discovery of quantum mechanics required abandoning the assumption that particles have definite positions and velocities. The discovery of 3-eye atlases pre-echoes might require abandoning the assumption that causes always precede effects, that time always flows in one direction, that the past is fixed and the future is open. But abandoning assumptions doesn't mean abandoning reason or evidence. Science progresses by carefully testing new ideas against observations, by demanding that theories make testable predictions, by being willing to be wrong. The mystery of 3-eye atlas will eventually be solved, or at least better understood, through this patient process of hypothesis and testing, theory and observation. It might take years or decades or centuries, but eventually we'll have a better answer than we don't know. Until then, we have the wonder. We have the questions that stretch our minds and expand our horizons. We have the reminder that we live in a universe full of surprises, where even the fundamental nature of time and causality can be called into question by a visiting chunk of interstellar ice and rock. We have the humility that comes from confronting our ignorance and the excitement that comes from the possibility of discovery. The pre-echoes continue to reverberate through human consciousness, inspiring not just scientists but artists, philosophers, writers, and dreamers. Songs have been written about 3-eye atlas, paintings created, poems composed. It has become a symbol of mystery and wonder in popular culture, a reminder that reality is stranger than fiction. Children learning about it in school are inspired to become astronomers, physicists, explorers of the cosmic unknown. This cultural impact might be 3-eye atlas's most lasting legacy. Long after the scientific mystery is solved, if it ever is, the story of the object that announced its arrival before it arrived will continue to inspire wonder and curiosity. It will join the pantheon of cosmic mysteries that have shaped human thought, from the ancient observations of planetary motion to the modern discovery of dark energy. As your eyes grow heavy and sleep beckons, you're entering a state where time becomes fluid, where past and future mix in the landscape of dreams. In this state, you're closer to 3-eye atlas than any telescope could bring you. You're experiencing time as it might be experienced by an object moving at tremendous speeds through curved space-time, where yesterday and tomorrow are just different directions you might travel. In your dreams tonight, you might see 3-eye atlas whole again, not fragmented but complete, sailing through the cosmic dark on its eternal journey. You might see the pre-echoes as they really are, not violations of causality but revelations of a deeper order we don't yet understand. You might even solve the mystery in that wordless way that dreams sometimes solve problems, waking with an intuition that can't quite be put into words but feels profoundly true. The universe doesn't reveal its secrets easily, but it does reveal them to those who search with patience and wonder. 3-eye atlas was one small piece of the cosmic puzzle, a hint about the deeper nature of reality. There will be others, other visitors from interstellar space, other anomalies that don't fit our theories, other mysteries that challenge our assumptions. Each one is an opportunity to learn, to grow, to expand our understanding of the cosmos and our place within it. The river of time flows on, carrying us from moment to moment, from discovery to discovery. But now we know that it's not a simple river, but something far more complex with eddies and currents, depths and shallows, and perhaps even places where the water flows backward, where echoes can precede voices, where the future can whisper to the past. Atlas showed us one such place, gave us one such whisper, and even if we don't yet understand what it said, we're grateful for the mystery, for the wonder, for the reminder that the universe is far more magnificent than we imagined. Sleep now approaches like a gentle tide, carrying you away from the world of causality and logic into the realm of dreams where anything is possible. In that realm, 3 Atlas makes perfect sense. Its pre-echoes as natural as echoes in a canyon, its fragmentation as beautiful as snow falling, its disappearance as peaceful as the setting sun. In dreams, you might travel with it through the cosmic dark, seeing sights no waking eye has seen, understanding truths no waking mind can grasp. The mystery remains, beautiful in its incompleteness, inspiring in its impossibility. Tomorrow, astronomers will continue their observations, theorists will refine their models, and somewhere in the vast cosmos, other objects like 3i Atlas will continue their journeys, carrying their secrets through the darkness between stars. Some of them might pass through our solar system, offering new clues, new mysteries, new opportunities for wonder. Others will pass unseen, their stories untold, their secrets kept. But tonight, as you drift into sleep, you can rest in the knowledge that you live in a universe of infinite mystery and beauty, where even the fundamental nature of time can surprise us, where visitors from interstellar space can challenge everything we thought we knew, where the impossible sometimes turns out to be possible after all. The pre-echoes of 3i Atlas have faded from our instruments, but they continue to echo in our minds, reminding us that reality is far stranger, far more wonderful than we ever dared to dream. The universe has always been a heretic, quietly defying our attempts to contain it within neat theories and tidy equations. Every time we think we've understood its rules, it shows us something that shouldn't exist, something that makes us question everything we thought we knew. 3i Atlas was perhaps the gentlest heresy yet. Not a violent overthrow of physics, but a soft suggestion that maybe, just maybe, we've been looking at everything from too narrow a perspective. It didn't break our theories so much as reveal their boundaries, like finding the edge of a map you thought depicted the whole world. Consider what we thought we knew before 3i Atlas arrived. Time flows forward, always and everywhere, from past through present to future. Causes precede effects. Information travels at or below the speed of light. Objects exist in definite states at definite times. These weren't just scientific principles. They were the foundation of how we understand reality itself, the bedrock upon which all of physics, all of causality, all of our daily experience rests. And then came this interstellar wanderer with its impossible pre-echoes, its gentle fragmentation, its synchronized pulsing, its complete disappearance. And suddenly those foundations didn't seem quite so solid anymore. The heresy of 3i Atlas wasn't loud or dramatic. It was a whisper that said, perhaps time isn't quite what we think it is. Perhaps causality has more flexibility than we imagined. Perhaps the universe operates according to principles that only become visible under extreme conditions, like the way certain crystals only reveal their true structure under specific wavelengths of light. The object didn't violate our physics so much as transcend it, showing us that what we call the laws of nature might be more like local ordinances, valid in our neighborhood but not necessarily universal. This gentle heresy has profound implications for how we think about reality. If effects can sometimes precede causes, even in limited ways, then the universe isn't the clockwork mechanism that classical physics imagined. It's not even the probabilistic quantum system that modern physics describes. It's something else, something that includes both of these descriptions but transcends them. Something that allows for connections between events that our current theories can't accommodate. The pre-echoes weren't just anomalous observations, they were glimpses of this deeper reality, like seeing the shadow of a four-dimensional object cast into our three-dimensional world. Dr. Elena Vasquez has spent the years since 3i Atlas's disappearance developing what she calls heretical physics, a framework that embraces the impossibilities that 3i Atlas revealed. Her approach doesn't throw out Einstein or quantum mechanics, but extends them into new territories. She starts with the assumption that our universe is embedded in a higher dimensional space, where time isn't a single dimension but multiple dimensions, where events can be connected through pathways that bypass normal causality. In this framework, the pre-echoes weren't violations of physics, but natural consequences of 3i Atlas's trajectory through this higher dimensional space. The mathematics of heretical physics is beautiful but challenging. It requires thinking about time not as a line, but as a surface, or even a volume, where events can be connected in ways that seem impossible from our limited perspective. Imagine living on the surface of a sphere but only being able to perceive one dimension, like an ant walking along a line drawn on a balloon. From the ant's perspective, it can only move forward or backward along the line, but if the line curves around the sphere and crosses itself, the ant might encounter its own past or future without understanding how. We might be like that ant, perceiving time as one-dimensional when it's actually far more complex. This multi-dimensional view of time could explain not just 3i Atlas, but other cosmic mysteries as well. Dark energy, the mysterious force accelerating the expansion of the universe, might be the influence of our universe's future state on its present, a kind of cosmic scale pre-echo pulling space-time toward a specific configuration. Dark matter might be ordinary matter that exists slightly outside our normal time dimension, gravitationally present but electromagnetically invisible, because it's not quite synchronized with our present moment. These ideas are speculative, but they show how 3i Atlas has opened new ways of thinking about old problems. The heresy goes deeper than physics. It touches on philosophy, on our understanding of free will and determinism. If the future can influence the past, are our choices really free? Or are we playing out a script that's already been written, with the illusion of choice created by our limited perception of time? These questions have been debated by philosophers for millennia, but 3i Atlas gives them new urgency and new dimensions. Perhaps free will and determinism are both true, but at different scales or in different dimensions of time. Perhaps our choices are free within our perceived timeline, but determined from a higher dimensional perspective. Some researchers have suggested that consciousness itself might play a role in these temporal phenomena, not in the mystical sense of consciousness creating reality, but in the scientific sense of observation collapsing quantum possibilities. The pre-echoes of 3i Atlas were incredibly faint, barely above the noise threshold, only detectable because we happened to be looking with exactly the right instruments at exactly the right time. What if consciousness, the act of observation, is what makes these faint temporal connections visible? What if there are pre-echoes all around us, all the time, but they only become real when observed? This leads to what Dr. Marcus Webb calls the participatory universe hypothesis. The universe isn't just something we observe, but something we participate in creating through our observations. Every measurement, every observation, every conscious awareness of a phenomenon helps to crystallize it from a cloud of possibilities into a definite reality. 3i Atlas might have existed in a superposition of states, simultaneously arriving and not arriving, fragmenting and not fragmenting, until our observations collapsed it into the specific sequence of events we recorded. But this raises a troubling question. If our observations partly create reality, how can we trust those observations to tell us about reality as it truly is? This is the heart of the heresy that 3i Atlas represents. It suggests that the universe might be fundamentally unknowable in its entirety, that our very attempts to understand it change it in ways we can't fully account for. We're not outside observers studying an independent reality. We're participants in a reality that responds to our participation. The fragments of 3i Atlas, in their synchronized pulsing before disappearing, seemed almost to be acknowledging this participatory relationship. The pattern of pulsing changed depending on which telescopes were observing, which wavelengths were being monitored. It was as if the object was responding to our attention, performing differently for different audiences. This could be explained by conventional physics, different instruments detecting different aspects of the same phenomenon, but the correlations were strange, almost as if the object knew it was being watched. Dr. Yuki Tanaka has proposed that 3i Atlas might have been what she calls a quantum macro object, something that maintained quantum coherence despite its macroscopic size. In quantum mechanics, particles can exist in superposition, being in multiple states simultaneously until observed. Usually this only happens at the microscopic scale, larger objects quickly decohere, their quantum properties averaged out into classical behavior. But under the extreme conditions of interstellar space, with near absolute zero temperatures and almost perfect isolation, perhaps larger objects can maintain quantum coherence for millions or billions of years. If 3I Atlas was a quantum macro object, its behavior starts to make more sense, though sense might be too strong a word. The pre-echoes could be explained by quantum retrocausality, where future measurements influence past states. The fragmentation could be a form of quantum splitting, where the object explored multiple possible configurations simultaneously. The synchronized pulsing could be quantum entanglement between the fragments, and the disappearance could be a final decoherence event, where observation by our instruments and proximity to the Sun finally collapsed its quantum state into something we can no longer detect. This quantum interpretation of 3I Atlas has led to proposals for new experiments. If we could create quantum macro objects in the laboratory, even tiny ones, we might be able to reproduce some of 3I Atlas's behavior. Several research groups are attempting to maintain quantum coherence in larger and larger systems, pushing the boundaries of what's possible. So far, the largest objects that have shown quantum behavior are still microscopic, but the technology is improving rapidly. Perhaps within our lifetime, we'll create our own miniature 3I Atlas in a laboratory, complete with pre-echoes and retrocausal effects. The heresy of 3I Atlas extends to our understanding of information itself. In classical physics, information is conserved. It can be transformed but not created or destroyed. In quantum mechanics, information becomes more subtle, encoded in quantum states that can be entangled across space. But 3I Atlas suggests something even stranger, that information might be able to flow across time as easily as it flows across space, that the future might be able to inform the past in ways that don't create paradoxes but do challenge our understanding of causality. Dr. James Harrison has developed a theory he calls temporal information dynamics, which treats information as a substance that can flow through space-time along geodesics, the shortest paths through curved space-time. Just as water flows downhill following the curvature of the landscape, information might flow along the curvature of space-time, sometimes taking paths that appear to violate causality from our limited perspective. The pre-echoes of 3I Atlas might have been information flowing along temporal geodesics that happened to pass through our present before the object itself arrived. This theory makes specific predictions about where and when pre-echoes should be observable. They should be stronger near massive objects that curve space-time significantly. They should be more common for objects moving at high velocities, where relativistic effects become important. They should be detectable in the cosmic microwave background radiation, the echo of the Big Bang itself. Several experiments are underway to test these predictions, though the signals, if they exist, are expected to be incredibly faint. The cultural impact of 3 Atlas's heresy has been as profound as its scientific impact. It has entered our collective consciousness as a symbol of the impossible made real, the unthinkable made observable. Artists have created works inspired by the concept of pre-echoes, sculptures that seem to cast shadows before they're built, music that somehow evokes memories of songs not yet written. Writers have explored the philosophical implications in fiction and non-fiction alike, imagining worlds where retrocausality is common, where effects routinely precede causes. But perhaps the most profound impact has been on how we think about knowledge itself. 3I Atlas showed us that our most fundamental assumptions about reality might be wrong, or at least incomplete. It reminded us that science is not a collection of eternal truths, but a process of continual revision, of replacing good theories with better ones, of expanding our understanding to encompass new phenomena. The heresy of 3 Atlas is really the heresy of science itself. The willingness to abandon cherished beliefs when confronted with contradictory evidence. This doesn't mean that anything goes, that all theories are equally valid, that we should abandon rigorous thinking in favor of wild speculation. The heresy of 3I Atlas is a gentle one. carefully documented, thoroughly analysed, constrained by observation and mathematics. It's not a rejection of science, but an extension of it into new territories. The pre-echoes don't invalidate causality. They suggest that causality might be more complex than we thought. The fragmentation doesn't violate conservation laws. It reveals new ways that matter and energy can be organised. As we contemplate this gentle heresy, it's worth remembering that the universe has no obligation to make sense to us. It existed for billions of years before humans evolved, and it will continue for billions of years after we're gone. The fact that we can understand any of it, that our minds can grasp even a fraction of its complexity, is itself a kind of miracle. 3 Atlas reminds us to be humble in our claims of understanding, to remain open to surprise, to embrace mystery as a fundamental aspect of existence. The object's journey through our solar system was brief, just a few months from detection to disappearance. But in that short time, it changed how we think about time, causality, and the nature of reality itself. It showed us that the universe is capable of behaviours we never imagined, that our theories are approximations rather than absolute truths, that there's always more to discover. It was a gentle teacher, offering its lessons through mystery rather than clarity, through questions rather than answers. Some scientists have suggested that 3I Atlas might have been exactly what the universe needed to show us at this moment in our development. Not earlier, when we lacked the instruments to detect it properly. Not later, when we might have been too set in our theories to recognise its significance. But now, when we're just sophisticated enough to observe it, but still humble enough to be amazed by it. This might be wishful thinking, anthropomorphizing a random cosmic event. But there's something poetic about the timing. The search for other objects like 3I Atlas has intensified since its disappearance. New surveys are being designed specifically to detect pre-echoes, to catch objects before they arrive. The Vera Rubin Observatory will scan the entire visible sky every few nights, sensitive enough to detect objects far fainter than the 3I Atlas. Radio telescopes are being synchronized to create planet-wide arrays capable of detecting the faintest whispers from space and time. We're developing new theories, new mathematics, new ways of thinking about the universe that can accommodate the heresy that 3I Atlas revealed. But even as we search for new mysteries, or as we continue to grapple with the one 3I Atlas left us, the data from its passage through our solar system is still being analysed, still revealing new patterns and correlations. Every few months, someone publishes a paper highlighting some aspect of its behaviour that hadn't been noticed before, some subtle detail that might be the key to understanding the whole phenomenon. The mystery deepens even as our understanding grows, like a fractal pattern that reveals new complexity at every scale. Dr. Sarah Chen, who discovered the first pre-echoes, has spent years developing a comprehensive theory she calls causal fluid dynamics. She treats causality not as a rigid structure, but as a fluid that can flow, eddy, and even reverse under certain conditions. In her model, 3I Atlas created what she calls a causal vortex, a whirlpool in the flow of cause and effect that allowed information to travel upstream. The mathematics is elegant, borrowing techniques from fluid dynamics and general relativity, but it makes predictions that are difficult to test with current technology. One prediction is that pre-echoes should be more common in regions of space where multiple gravitational fields interact, creating what Chen calls causal turbulence. These regions might be near binary star systems, at the edges of galaxies, or in the vast voids between galactic clusters. Another prediction is that certain types of matter might be more susceptible to creating pre-echoes, particularly matter with unusual quantum properties or extreme densities. These predictions are guiding the next generation of observations, focusing our search for other heretical objects. The philosophical implications of Chen's theory are profound. If causality is fluid rather than fixed, then our entire notion of past, present, and future might need revision. Events might not be strictly ordered in time, but might exist in a more complex relationship, influencing each other in ways that transcend simple, before and after. This doesn't mean that everything is predetermined or that free will is an illusion, but it does suggest that the relationship between cause and effect, choice and consequence, is far more nuanced than we imagined. As night deepens and your consciousness continues its gentle drift towards sleep, the heresy of the Atlas seems less heretical and more natural. In the drowsy space between waking and sleeping, where logic relaxes its grip and imagination takes flight, the idea of effects preceding causes doesn't seem so strange. Dreams routinely violate causality, mixing past and future, combining the impossible with the mundane. Perhaps dreams are glimpses of how the universe really works, unconstrained by our waking insistence on linear time and simple causality. The fragments of 3i Atlas in their final moments before disappearing seemed to pulse in harmony with something we couldn't see or measure. Perhaps they were synchronizing with the gravitational waves that ripple through space-time, or with the quantum fluctuations that bubble up from the vacuum, or with something else entirely, something we don't have words or concepts for yet. Their disappearance wasn't a destruction, but a transformation. A transition to a state we can't detect, but that might be all around us. Consider the possibility that 3i Atlas didn't really disappear, but simply moved outside our ability to perceive it. Just as there are sounds too high or low for us to hear, colours beyond what our eyes can see, perhaps there are states of matter and energy that our instruments can't detect. The object might still be there, continuing its journey through the solar system, but in a form that doesn't interact with electromagnetic radiation or any of the other forces we can measure. It might be dark matter now, or something even more exotic. This idea that there might be vast realms of reality we can't perceive is both humbling and exciting. It means that the universe is far richer than we know, full of phenomena and possibilities we haven't even imagined. 3 Atlas gave us a glimpse of these hidden realms, a brief window into aspects of reality that normally remain invisible. Its pre-echoes were like shadows cast from higher dimensions, its fragmentation like a flower blooming in dimensions we can't see, its disappearance like a door closing on a room we didn't know existed. The heresy of 3i Atlas has become a rallying cry for a new generation of scientists who are willing to question fundamental assumptions, to explore impossible ideas, to embrace mystery as a driver of discovery. They call themselves post-causal physicists or temporal revolutionaries, and they're developing theories that would have seemed like fantasy just a few years ago. Some propose that time is emergent rather than fundamental, arising from more basic processes we don't yet understand. Others suggest that causality is a local phenomenon, valid in our region of space-time but not universal. These new theories are controversial to say the least. Many established physicists view them with skepticism, arguing that they're too speculative, too divorced from experimental verification, and they have a point. It's easy to create elaborate mathematical frameworks that explain anomalies. It's much harder to create theories that make testable predictions. But the young revolutionaries argue that 3i Atlas has shown us that nature is more imaginative than we are, that we need to think more boldly if we're going to understand phenomena that transcend our current theories. The debate between conservative and revolutionary approaches to understanding 3 Atlas reflects a broader tension in science between maintaining rigorous standards and remaining open to new ideas. Both approaches are necessary. Without skepticism and careful verification, science would devolve into speculation and wishful thinking. But without openness to new ideas, even heretical ones, science would stagnate, unable to accommodate new phenomena that don't fit existing theories. 3i Atlas has become a test case for how science handles anomalies that challenge fundamental assumptions. Do we try to explain them within existing frameworks, even if the explanations become increasingly convoluted? Do we modify our theories slightly, adding new terms or parameters to accommodate the observations? Or do we consider the possibility that our entire framework might be wrong, that we need to start over with radically different assumptions? There's no easy answer, and different scientists take different approaches. Dr. Harrison at Oxford has been working on what he calls a minimalist interpretation of 3i Atlas. He argues that we don't need to abandon causality or invoke extra dimensions to explain what we observed. Instead, he suggests that 3i Atlas was made of a type of matter that interacts with space-time in unusual ways, creating the appearance of pre-echoes through a combination of gravitational lensing, quantum effects, and measurement artifacts. His explanation is complex and requires several unlikely coincidences, but it preserves our fundamental understanding of physics. On the other extreme, Dr. Biera Tanaka in Tokyo has proposed what she calls the maximalist interpretation. She argues that 3i Atlas is evidence that our entire understanding of reality is fundamentally flawed, that we need to rebuild physics from the ground up based on different principles. In her view, 3i Atlas was a messenger from a realm of physics we haven't discovered yet, showing us that our theories are not just incomplete, but wrong in some basic way. She's working on a new framework based on information theory and quantum mechanics that treats space-time as emergent rather than fundamental. Between these extremes, most scientists are taking a middle path, acknowledging that 3i Atlas revealed something important about the universe, while remaining cautious about abandoning well-tested theories. They're developing extensions to existing physics that can accommodate pre-echoes and other anomalous behaviors, while preserving the successful predictions of relativity and quantum mechanics. It's a delicate balance, trying to be revolutionary enough to explain new phenomena while conservative enough to maintain scientific rigor. The heresy of 3i Atlas extends beyond physics into our broader worldview. It challenges the notion that we're approaching a complete understanding of the universe, that we're close to a theory of everything that will explain all phenomena. Instead, it suggests that the universe might be inexhaustibly complex, always capable of surprising us with new behaviors and phenomena. This is both daunting and exhilarating. Daunting because it means our quest for understanding might never end. Exhilarating because it means there will always be new mysteries to explore, new wonders to discover. As you continue to relax, letting the gentle rhythm of your breathing carry you towards sleep, the universe's gentle heresy seems less like a challenge and more like an invitation. An invitation to wonder, to question, to explore. An invitation to admit that we don't have all the answers and might never have them all. An invitation to embrace mystery as a fundamental aspect of existence, not a problem to be solved, but a gift to be appreciated. The pre-echoes of 3 Atlas continue to reverberate through human consciousness, not as sound waves or electromagnetic radiation, but as ideas, questions, possibilities. They've changed how we think about time, about causality, about the nature of reality itself. They've shown us that the universe is more creative than we imagined, more willing to violate our expectations, more generous with its mysteries. They've reminded us that we're still children in our understanding, still learning to read the cosmic story that surrounds us. Somewhere in the universe right now, other objects like 3i Atlas might be traveling between stars, carrying their own mysteries, their own challenges to our understanding. Some might show even stranger behaviors, even more impossible phenomena. Others might be perfectly ordinary, confirming our theories rather than challenging them. But each one is a message from the cosmos, a piece of the vast puzzle we're trying to assemble, a note in the symphony of existence. The search continues, with new instruments, new theories, new generations of scientists eager to push the boundaries of knowledge. They're guided by the lesson of 3i Atlas, that the universe is capable of surprises, that our theories are always provisional, that mystery is not the enemy of understanding but its companion. They're prepared for anything, or at least they think they are. The universe has a way of exceeding our preparations, of showing us wonders we couldn't have imagined. As sleep approaches, bringing its own mysteries and revelations, you can rest in the knowledge that you live in a universe that's far more interesting than we ever suspected. A universe where effects can precede causes, where objects can fragment in perfect synchronization, where things can disappear completely without explanation. A universe that's willing to be heretical, to violate our expectations, to teach us through mystery rather than clarity. It's a universe worth exploring, worth wondering about, worth losing sleep over, and worth dreaming about. The gentle heresy of Three-Eye Atlas has become part of our cultural DNA, a reminder that reality is stranger than we know. It's influenced not just science, but art, literature, philosophy, even theology. It's changed how we think about knowledge, about certainty, about the limits of human understanding. It's shown us that the universe doesn't owe us explanations, that some mysteries might remain forever mysterious, and that's okay. The mystery itself is valuable, beautiful, worthy of contemplation. In the quantum mechanical description of reality, observation plays a crucial role in determining what becomes real from a sea of possibilities. Perhaps our observation of Three-Eye Atlas, our detection of its pre-echoes, our measurement of its properties played a role in determining its behavior. Perhaps it fragmented and disappeared because we observed it, or perhaps we observed it because it was always going to fragment and disappear. The causality is unclear. The relationship between observer and observed remains mysterious. This brings us back to the participatory universe hypothesis, the idea that we're not passive observers, but active participants in the unfolding of reality. Every observation, every measurement, every conscious awareness of a phenomenon helps to shape what that phenomenon becomes. Three-Eye Atlas might have been in a superposition of many possible states until our observations collapsed it into the specific sequence of events we recorded. In this view, we didn't just observe Three-Eye Atlas, we helped create it, or at least help determine what form it took. But if we're participants rather than observers, what does that mean for scientific objectivity? How can we study a universe that responds to our studying? This is the deepest heresy of all, the suggestion that the separation between observer and observed, subject and object, might be an illusion. We're part of the universe we're trying to understand, made of the same matter, governed by the same forces, subject to the same mysteries. We're the universe trying to understand itself, and perhaps that self-referential loop creates paradoxes and impossibilities like the pre-echoes of Three-Eye Atlas. The fragments of Three-Eye Atlas before they disappeared seem to acknowledge this participatory relationship. Their synchronized pulsing appeared to respond to our observations, changing patterns when different telescopes pointed at them, varying their rhythm when observed at different wavelengths. It was as if they were dancing with us, responding to our attention, participating in a cosmic dialogue we didn't fully understand. This might be anthropomorphizing a natural phenomenon, reading intention into random events, but the correlations were striking. Some researchers have suggested that consciousness itself might be the key to understanding Three-Eye Atlas and similar phenomena. Not consciousness as some mystical force, but as a physical process that can influence quantum systems. The theory of quantum consciousness, while controversial, suggests that conscious observation might play a fundamental role in the collapse of quantum wave functions. If Three-Eye Atlas was a quantum macro object, our conscious observation of it might have influenced its behavior in ways we're only beginning to understand. This doesn't mean that we created Three-Eye Atlas with our minds or that reality is subjective. It means that the relationship between consciousness and physical reality might be more intimate than we thought, that the universe might be set up in such a way that conscious observers play a necessary role in determining what becomes real from the realm of quantum possibilities. It's a heretical idea, one that challenges the materialist assumption that consciousness is just an emergent property of complex physical systems. But Three-Eye Atlas has taught us to be open to heretical ideas, to question our assumptions, to remain humble in the face of cosmic mystery. Perhaps consciousness is more fundamental than we thought. Perhaps the universe requires observers to actualize its potential. Perhaps Three-Eye Atlas was showing us not just new physics, but a new relationship between mind and matter, between observation and reality, between consciousness and cosmos. As you drift closer to sleep, these ideas become less abstract, more felt than thought. In the drowsy space before dreams, the boundaries between self and universe begin to blur. You're made of star stuff, atoms forged in cosmic furnaces, arranged temporarily in a pattern that can contemplate its own origins. You're the universe becoming aware of itself, developing the capacity to wonder about mysteries like Three-Eye Atlas. In a very real sense, you're not separate from the cosmic mystery, but part of it, a temporary arrangement of matter and energy that can appreciate beauty, experience wonder, and ask why. The heresy of Three-Eye Atlas is ultimately a gentle reminder that we don't have everything figured out, that the universe still has surprises in store, that reality is far more magnificent and strange than our theories suggest. It's an invitation to maintain what Zen Buddhism calls beginner's mind, the openness and wonder of someone encountering something for the first time. Even after centuries of scientific progress, we're still beginners in our understanding of the cosmos, still children playing on the shore of an infinite ocean. The pre-echoes have faded from our instruments, the fragments have disappeared, the immediate mystery has passed. But the questions remain, reverberating through human consciousness like ripples on a pond that never quite settle. What was Three-Eye Atlas? Where did it come from? Why did it behave the way it did? What was it trying to tell us, if anything? These questions might never be fully answered, but the asking itself has value. Keeps us curious, keeps us searching, keeps us humble. Somewhere in the universe, right now, other mysteries are unfolding. Other objects are violating our expectations. Other phenomena are challenging our theories. Other heresies are waiting to be discovered. Three-Eye Atlas was just one note in a vast cosmic symphony we're only beginning to hear. Each new discovery adds another note, another layer of complexity and beauty. The symphony will never be complete, will never be fully understood, but we can appreciate its beauty even in our ignorance. The universe's gentle heresy continues, not just in exotic objects from interstellar space, but in everyday phenomena we take for granted. The fact that matter exists at all, that stars shine, that life emerged from non-life, that consciousness arose from unconscious matter, these are all heresies against the notion of a simple, predictable, comprehensible universe. Reality is far stranger than we usually acknowledge, far more mysterious than our daily experience suggests. As sleep finally claims you, carrying you into the realm of dreams where causality is fluid and mystery is commonplace, you can rest in the knowledge that you're part of something magnificent and strange. The universe that created Three-Eye Atlas also created you, and the same forces that governed its impossible journey govern your existence. You're part of the same cosmic story, the same unfolding mystery, the same gentle heresy against simplicity and predictability. Tomorrow you'll wake to a world that seems solid and sensible, where causes precede effects, and objects don't announce their arrival before they arrive. But now you know that beneath that apparent normalcy lies a reality far stranger, where the impossible sometimes happens, where our deepest assumptions can be overturned by a chunk of ice and rock from interstellar space. The universe has shown you its capacity for surprise, for mystery, for gentle heresy, and that knowledge will stay with you. A reminder that reality is far more wonderful than we dare to imagine. The story of Three Atlas continues in the work of scientists around the world, in the dreams of those who heard its tale, in the questions it raised that ripple outward through human consciousness. It continues in you, in your wonder and curiosity, in your willingness to contemplate the impossible. The gentle heresy lives on, not as a rejection of understanding, but as an expansion of it. Not as a problem to be solved, but as a mystery to be appreciated. Not as an ending, but as a beginning of new ways of thinking about the cosmos and our place within it. We're approaching the shores of sleep now, where the ocean of dreams meets the land of waking consciousness. Like Three-Eye Atlas approaching our solar system, you're crossing a boundary between different states, different ways of being. In dreams, you might understand Three Atlas in ways that elude waking analysis. You might see the pre-echoes as they really are, experience the fragmentation from the inside, comprehend the disappearance as transformation rather than ending. Dreams have their own physics, their own causality, their own relationship with time. Perhaps they're closer to the truth than we imagine. The small boat of human consciousness drifts on a boundless ocean, an ocean of space and time, matter and energy, known and unknown. We've built this boat ourselves, plank by plank, theory by theory, observation by observation. It's a sturdy vessel, capable of carrying us through cosmic storms and into unexplored waters, but 3i Atlas reminded us that the ocean is vast beyond imagining, that there are currents we don't understand, depths we've never plumbed, shores we've never seen. We're explorers on an infinite sea, and we've only just begun our voyage. Picture yourself in that small boat now, drifting on calm waters under a star-filled sky. The boat rocks gently with the rhythm of cosmic waves, waves that have travelled across billions of light-years to reach you. Each star you see is a sun, perhaps warming worlds we'll never know, perhaps watching their own 3i Atlas pass through, perhaps wondering about the same mysteries that perplex us. You're not alone in your wondering. If consciousness exists elsewhere in the universe, it too must grapple with the inexplicable, must confront phenomena that challenge its understanding, must remain humble before the cosmic mystery. The boat that carries us, this vessel of human knowledge and understanding, is both remarkable and fragile. Remarkable because it has brought us so far from our origins, from primitive ignorance to sophisticated theories about the nature of reality. Fragile because it can be overturned by a single observation. A single object like 3i Atlas that doesn't fit our carefully constructed worldview. But perhaps that fragility is actually a strength. A boat that can't be overturned, can't be improved, can't be rebuilt to navigate new waters. 3i Atlas overturned our boat, or at least rocked it severely. The pre-echoes challenged our understanding of causality. The fragmentation defied our models of how objects behave. The synchronized pulsing suggested connections we couldn't explain. The disappearance left us with questions that might never be answered, but we didn't drown. We rebuilt our boat, incorporating what we learned, making it capable of navigating waters where effects can precede causes, where the impossible sometimes happens. The ocean we're sailing isn't just made of space, but of time, not just of matter, but of information, not just of the known, but of the unknowable. 3i Atlas showed us that this ocean has properties we never suspected, currents that flow backward, depths where different rules apply. It revealed that our maps of reality are incomplete, that there are entire continents of possibility we haven't discovered yet. We're like ancient mariners who thought the world ended at the horizon, only to discover that the horizon keeps receding as we sail toward it. Dr. Chen's latest work suggests that the ocean metaphor might be more than poetic. She proposes that space-time might actually have fluid properties at certain scales, that it might flow and eddy like water, creating the kinds of phenomena we observed with 3i Atlas. In regions where space-time is turbulent, perhaps near massive objects or in the wake of cosmic catastrophes, causality itself might become fluid, allowing for pre-echoes and other temporal anomalies. We might be sailing on an ocean more literal than we imagined. This fluid space-time hypothesis makes specific predictions. It suggests that gravitational waves, ripples in space-time caused by accelerating masses, might sometimes carry information backward in time, creating pre-echoes of cosmic events. It predicts that the merger of black holes or neutron stars might be preceded by faint signals, whispers from the future catastrophe. Several gravitational wave detectors are now searching for these signals, listening for tomorrow's disasters echoing backward to today. The small boat of human consciousness isn't sailing alone. We're part of a vast fleet, though we can't see the other vessels. Every conscious being in the universe, if they exist, is on their own voyage of discovery, building their own boats of understanding, confronting their own impossible objects. Perhaps some of them have encountered phenomena even stranger than 3i Atlas, have developed theories that would seem like magic to us. have learned to navigate regions of the cosmic ocean we can't even imagine. The search for extraterrestrial intelligence has traditionally focused on radio signals and other electromagnetic communications, but perhaps the real evidence of other intelligences is in the anomalies, the things that don't fit our theories. Not because they're artificial necessarily, but because they might have been observed and understood by others who left some kind of mark, some subtle influence we don't recognize. 3C Atlas might have been studied by countless civilizations over its long journey, each adding their own interpretations, their own theories, to a cosmic conversation we're just beginning to join. Or perhaps we're alone on this ocean, the only conscious observers in a universe of beautiful but unconscious processes. If so, our responsibility is even greater. We're the only witnesses to cosmic mysteries like 3I Atlas, the only ones capable of wonder and understanding. The universe has produced in us the capacity to appreciate its own beauty and mystery. We're the ocean becoming aware of itself, developing the ability to map its own currents, to understand its own depths. The fragments of 3I Atlas, before they disappeared, seem to pulse with a rhythm that some researchers have compared to a heartbeat or breathing. This might be pure imagination, seeing patterns where none exist. But there's something poetic about the idea. Perhaps the universe has a pulse we're only beginning to detect, a rhythm that manifests in phenomena like 3I Atlas. Perhaps what we call laws of physics are really just the observable patterns of this cosmic breathing, and the anomalies are moments when the universe holds its breath or sighs. As you float in your small boat on this boundless ocean, you can feel that rhythm in your own breathing, your own heartbeat. You're not separate from the cosmic pulse, but part of it, a temporary pattern in the vast flow of matter and energy. Your consciousness is like a wave on the ocean, arising from the depths, cresting briefly in awareness, then returning to the vast unconscious from which it came. But while you crest, while you're aware, you can appreciate the beauty of the ocean, the mystery of existence, the wonder of being. The journey of 3 Atlas through our solar system was like a message in a bottle, washing up on our shore after eons of drifting through the cosmic ocean. We couldn't fully read the message, couldn't understand all its implications, but we recognized it as something important, something that challenged our understanding of how messages can be sent, how bottles can drift, how shores can receive visitors from the deep. The message might not have been intended for us specifically, might not have been intended at all, but we received it nonetheless, and it changed us. Every scientific observation is like finding a message in a bottle, a communication from the universe about its own nature. Most of these messages are simple, confirming what we already know. But occasionally we find one like 3I Atlas that's written in a language we don't understand, that tells us about parts of the ocean we didn't know existed. These are the messages that advance our understanding, that force us to build better boats, to sail farther from familiar shores. The ocean of space-time that we're sailing through isn't empty but full of invisible currents and hidden structures. Dark matter creates gravitational currents we can feel but not see. Dark energy drives an expansion we can measure but not explain. Quantum fluctuations create a foam of possibility at the smallest scales. And perhaps there are other structures we haven't discovered yet, other currents that carried 3I Atlas to our shore, other forces that created its pre-echoes and governed its disappearance. Dr. Vasquez has proposed that what we call dark matter might actually be ordinary matter that exists in a slightly different temporal phase, offset from our present by a fraction of a second. It would be gravitationally present but electromagnetically invisible, because its light would be arriving too early or too late for us to detect. This would explain why dark matter seems to follow ordinary matter, but doesn't interact with it except through gravity. It would also suggest that 3I Atlas might have been partially composed of this temporally shifted matter, existing partly in our present and partly in our immediate future or past. This temporal phase theory of dark matter is highly speculative, but it shows how 3 Atlas has opened new ways of thinking about old problems. If matter can exist in different temporal phases, it might explain not just dark matter but other cosmic mysteries as well. The accelerating expansion of the universe might be driven by matter in future phases pulling space-time forward. The cosmic web of galaxies might be shaped by temporal currents we can't directly detect. The entire structure of the universe might be determined by interactions between different temporal phases of matter and energy. As you continue to drift in your small boat, the stars reflected in the calm water around you, it becomes harder to tell where the ocean ends and space begins. The boundary between inner and outer, between self and cosmos, becomes fluid. You're sailing through space on a planet that's a boat. You're sailing through time in a body that's temporary. You're sailing through consciousness in a mind that arose from unconscious matter. Boundaries within boundaries, boats within boats, all sailing on the same boundless ocean. The pre-echoes of 3i Atlas might have been reflections like stars reflected in water, showing us something real but from an unusual angle. Just as you can sometimes see around corners using reflections, perhaps we saw around the corner of time using some cosmic reflection we don't understand. The object's image arrived before the object itself, carried by some exotic process that transcends our normal understanding of how images propagate through space and time. This reflection hypothesis, proposed by a team at the Kavli Institute, suggests that space-time might have reflective properties under certain conditions. Just as electromagnetic waves can be reflected by conducting surfaces, perhaps gravitational waves or quantum information can be reflected by certain configurations of matter or energy. These reflections might travel faster than light without violating relativity, taking shortcuts through higher dimensions or quantum tunnels. 3i Atlas might have encountered such a reflective surface on its journey, creating the pre-echoes we observed. The search for these cosmic mirrors has become a new field of astronomy. Researchers are looking for regions of space where pre-echoes might be more common, where the geometry of space-time might create natural reflectors. They're studying the cosmic web, the vast network of dark matter filaments that connects galaxies, wondering if these structures might act as temporal mirrors. They're examining the boundaries between cosmic voids and dense regions, places where the fabric of space-time might be stressed enough to create reflective properties. But perhaps we're thinking too literally about reflections and mirrors. Maybe the entire universe is reflective in a deeper sense, with every event creating echoes that propagate both forward and backward in time. We only notice the forward echoes because that's the direction we perceive time flowing, but 3i Atlas, with its unusual properties, might have made the backward echoes visible, showing us a fundamental aspect of reality we normally can't perceive. The small boat of human understanding has room for many passengers, many perspectives, many ways of interpreting the cosmic mystery. Scientists bring their equations and observations. Philosophers bring their questions and frameworks. Artists bring their intuitions and visions. Everyone who has wondered about 3i Atlas, everyone who has contemplated its mystery, is a passenger on this boat, contributing to our collective journey toward understanding, and what a journey it has been. From the first detection of 3i Atlas to its disappearance near the Sun, from the discovery of pre-echoes to the development of new theories to explain them, we've sailed through uncharted waters, discovering new aspects of reality we never suspected. We've had to rebuild our boat several times, replacing old planks of certainty with new ones of possibility. We've had to draw new maps, marking regions where causality becomes fluid, where time flows in circles, where the impossible becomes possible. The boat is stronger now, more seaworthy, better able to handle the storms of paradox and waves of mystery. But it's also more humble, more aware of its limitations. We know now that our boat is tiny compared to the ocean it sails. We know that our maps are incomplete, our instruments imperfect, our understanding provisional. But we also know that we're capable of growth, of learning, of adapting to new revelations. 3i Atlas taught us that, showed us that we can confront the impossible and emerge not with answers but with better questions. As you rock gently in your boat, the rhythm of the waves matching your breathing, you're participating in the same cosmic dance that governed 3i Atlas's journey. The same forces that carried it through interstellar space carry you through your life. The same mysteries that surrounded its behavior surround your consciousness. You're not just an observer of the cosmic mystery, but part of it. A wave in the same ocean, a note in the same symphony. The ocean is patient with our small boat, our limited understanding. It doesn't demand that we comprehend its depths all at once. It reveals its mysteries slowly, one three-eye atlas at a time, giving us generations to absorb each revelation. This patience is a gift, allowing us to maintain our sanity while confronting the infinite. If we understood everything at once, if all the universe's mysteries were suddenly revealed, we might be overwhelmed, like a small boat swamped by a tsunami of truth. Instead, we get gentle waves of discovery, each one pushing us a little farther from the familiar shore, each one expanding our horizons slightly. 3 Atlas was one such wave, larger than most, carrying us into waters we'd never navigated before. But there will be other waves, other discoveries, other objects that challenge our understanding. The ocean is infinite, and we've only explored the tiniest fraction of it. Dr. Harrison's recent work on what he calls temporal navigation suggests that we might eventually learn to sail through time as easily as we sail through space. Not time travel in the science fiction sense, but the ability to detect and interpret temporal currents, to predict where and when pre-echoes might occur, to understand the flow of causality well enough to anticipate anomalies. We might become temporal navigators, reading the patterns of past and future like ancient mariners read the stars. This would require a fundamental shift in how we think about time, from a fixed backdrop against which events occur to a dynamic medium that can be mapped and navigated. 3-eye Atlas might have been our first glimpse of this temporal ocean, showing us that it has currents and depths we never suspected. Future discoveries might teach us to read these currents, to understand the weather patterns of time, to predict temporal storms and find temporal harbours. But for now, we drift on the surface, occasionally glimpsing the depth through phenomena like 3-eye Atlas, mostly unaware of the vast complexity beneath us, and perhaps that's as it should be. We're not ready to navigate the temporal ocean fully. We're still learning to handle our small boat on the surface, still mapping the visible stars, still coming to terms with the vastness of space. The depths of time can wait for future generations, future voyagers who will build on our discoveries and sail farther than we ever could. The disappearance of 3-eye Atlas near the sun might not have been an ending but a transformation, like a caterpillar entering a chrysalis. Perhaps it emerged in a form we can't detect, continuing its journey through dimensions we can't perceive. Perhaps it's still out there, or in there, or when there, existing in a state that transcends our concepts of space and time. The ocean it sails might be vaster than the one we know, with realms of existence we haven't imagined. Some researchers have suggested that 3-eye Atlas might have been a natural probe, not designed by intelligence but shaped by the cosmos itself to explore different regions of space-time and report back through mechanisms we don't understand. The pre-echoes might have been its reports, transmitted through temporal channels to some cosmic database we can't access. We intercepted these reports by accident, like picking up a radio transmission meant for someone else, understanding just enough to know we don't understand. This idea of natural probes, objects that evolve in interstellar space to gather and transmit information, is speculative but not impossible. The universe has created structures far more complex than 3-eye Atlas through natural processes. Stars, planets, and life itself arose without design or intention. Perhaps there are other forms of cosmic organization we haven't recognized, other ways that matter and energy can arrange themselves to process and transmit information. The small boat of human consciousness continues its journey, carried by currents it doesn't fully understand toward destinations it can't foresee. But the journey itself has meaning, has beauty, has value beyond any destination. Every moment of wonder, every question asked, every mystery contemplated adds to the richness of the voyage. 3 Atlas was a gift to our journey, a moment of extraordinary mystery that will ripple through human consciousness for generations. As you approach the shores of sleep, your small boat finding a quiet harbour in the ocean of dreams, you can rest knowing that you're part of something magnificent. The same universe that created 3i Atlas created you, and the same mysteries that surrounded it surround your existence. You're a passenger on a cosmic voyage that began with the Big Bang and will continue for billions of years. Your brief moment of consciousness, your ability to wonder about objects like 3i Atlas, is part of the universe's attempt to understand itself. The ocean rocks you gently towards sleep, the stars above reflecting in the calm waters around your boat. Somewhere in that ocean, the fragments of 3i Atlas might still exist in some form, continuing their eternal voyage. Somewhere other objects like it might be approaching other star systems, carrying their own mysteries, their own challenges to understanding. Somewhere, conscious beings might be grappling with their own impossible observations, building their own boats of theory and speculation. But here and now, in this moment between waking and sleeping, you float peacefully on the boundless ocean, a small boat carrying the light of consciousness through the cosmic dark. The mystery of 3i Atlas has become part of your cargo, part of what you carry forward into tomorrow. It has enriched your journey, expanded your horizons, reminded you that the ocean is vast and full of wonders, and that knowledge, that wonder, that humility before the cosmic mystery is perhaps the greatest gift 3i Atlas could have given us. The ocean of existence stretches infinitely in all directions, through space and time, matter and mind, known and unknown. Your small boat is both insignificant and precious, a tiny vessel carrying something remarkable, the capacity to appreciate beauty, to experience wonder, to ask why. 3. Atlas reminded us of this capacity, renewed our sense of wonder, reinvigorated our curiosity. It showed us that even after centuries of science, we're still capable of being surprised, still able to confront mystery with humility and awe. And now, as sleep finally claims you, your small boat finds safe harbour in the realm of dreams. The ocean continues its eternal rhythms, waves lapping gently against the shore of consciousness. Tomorrow you'll wake and resume your voyage, but for now, you rest, rocked by cosmic currents, surrounded by mystery, part of the same boundless ocean that carried 3i Atlas through our lives and into legend. The journey continues, the mystery deepens, the wonder never ends. The beauty of the unanswered question is that it keeps us searching, keeps us growing, keeps us humble. 3i Atlas gave us a question so beautiful, so profound, that it might be worth more than any answer. Did it arrive before it left? Did we see echoes from tomorrow? Did causality bend in its presence? These questions have no easy answers, perhaps no answers at all, but they've enriched our understanding of what questions are possible, what mysteries the universe might hold. Think about the most beautiful questions in science. Why does anything exist rather than nothing? How did life begin? What is consciousness? These questions drive us forward, inspire generations of seekers, create entire fields of study. They're valuable not because they can be answered definitively, but because the search for answers teaches us so much about ourselves and our universe. 3i Atlas has added a new question to this pantheon. Can the future influence the past? It's a question that might take centuries to answer, or might never be answered, but the asking itself has already taught us so much. The pre-echoes of 3i Atlas were like questions asked backward, answers that preceded their queries. They showed us that our normal way of thinking about questions and answers, problems and solutions might be too limited. Perhaps some answers exist before we know what questions to ask. Perhaps some solutions are waiting for us to discover the problems they solve. The universe might be full of answers floating free, waiting for conscious beings to develop the questions that give them meaning. Dr. Chen has recently proposed what she calls the question-answer duality, suggesting that questions and answers might be like particles and waves in quantum mechanics. two aspects of the same phenomenon that appear different depending on how we observe them. From one perspective, 3i Atlas posed questions about the nature of time and causality. From another perspective, it provided answers to questions we hadn't yet learned to ask. The pre-echoes might have been answers arriving before we knew the questions, creating a kind of temporal paradox that reveals deep truths about the nature of knowledge itself. This philosophical dimension of 3i Atlas has attracted attention from beyond the scientific community. Philosophers have written extensively about what it means for an answer to precede its question, for an effect to precede its cause. Some see it as validation of ancient philosophical ideas about the unity of opposites, the circular nature of time, the interconnectedness of all things. Others see it as a challenge to the very foundations of logic and reason, suggesting that the universe might not be fully comprehensible to minds that evolved to understand simple cause and effect. Theologians have also grappled with the implications of 3i Atlas. If the future can influence the past, what does that mean for free will, for divine providence, for the nature of prophecy? Some see the pre-echoes as evidence of a universe where all moments exist simultaneously in the mind of God, where past, present, and future are human constructs that don't apply to ultimate reality. Others see them as proof that the universe is more mysterious than any theology has imagined, that our spiritual frameworks are as provisional as our scientific ones. Artists have found in 3i Atlas a perfect metaphor for the creative process. Inspiration often feels like it comes from nowhere or from the future, like we're discovering something that already exists rather than creating something new. The pre-echoes resonate with the experience of having a vision of a completed work before beginning to create it, of knowing the answer before fully understanding the question. 3i Atlas has become a muse for creators, a symbol of the mysterious nature of creativity itself. But perhaps the most beautiful aspect of the unanswered question of 3i Atlas is how it has brought people together. Scientists from different disciplines, from different countries, from different theoretical backgrounds have collaborated to try to understand it. The mystery has created a community of wonder, a global conversation about the nature of reality. It has reminded us that we're all in this together, all passengers on the same cosmic journey, all equally mystified by the depths of existence. The data from 3i Atlas continues to be analysed years after its disappearance. New patterns are still being discovered, new correlations identified. Each research paper adds a small piece to the puzzle, though the overall picture remains unclear. It's like assembling a jigsaw puzzle, without knowing what the final image should be, without even knowing if all the pieces are from the same puzzle. But the process itself has value, teaches us patience, humility, and persistence. Some researchers have suggested that we might be approaching the mystery of 3i Atlas from the wrong angle, that we're asking the wrong questions. Instead of asking how pre-echoes are possible, maybe we should ask why we normally don't see them. Instead of asking why 3i Atlas fragmented, maybe we should ask why most objects don't. Instead of asking where it went when it disappeared, maybe we should ask where it came from in the first place. Sometimes the most beautiful questions are the ones that invert our assumptions, that make us see familiar things in unfamiliar ways. The beauty of unanswered questions is that they leave room for imagination, for possibility, for hope. If we knew exactly what 3i Atlas was, how it created pre-echoes, why it behaved the way it did, some of the wonder would be lost. The mystery keeps it alive in our consciousness, keeps us thinking about it, dreaming about it, creating new theories and possibilities. An answered question is closed, finished. An unanswered question is open, infinite, full of potential. Children learning about 3i Atlas in school often come up with explanations that make professional scientists pause and think. Maybe it was a time machine. Maybe it was a message from another dimension. Maybe it was a cosmic bubble that popped. These naive theories sometimes contain insights that more sophisticated approaches miss. The beauty of the unanswered question is that it makes us all equals in our ignorance, all capable of contributing to the search for understanding. The synchronized pulsing of the fragments before they disappeared, remains one of the most beautiful and mysterious aspects of Three-Eye Atlas. The pattern, when converted to sound, creates a haunting melody that some composers have incorporated into their work. When visualized, it creates fractal patterns that artists have used in paintings and sculptures. It's as if Three-Eye Atlas was not just a scientific phenomenon, but an aesthetic one, bringing beauty as well as mystery into our lives. Dr. Tanaka has suggested that beauty and truth might be more connected than we realize, that the universe tends toward beautiful solutions to its problems. The equations of physics are often surprisingly elegant, even when describing complex phenomena. The patterns in nature, from spiral galaxies to nautilus shells, follow mathematical relationships that we find aesthetically pleasing. Perhaps Three-Eye Atlas was showing us a new kind of beauty, a temporal beauty that we don't yet have the vocabulary to describe. This connection between beauty and truth, between aesthetics and physics, suggests that our sense of beauty might be a tool for understanding the universe. When something feels beautiful, it might be because it resonates with deep patterns in reality. The pre-echoes of Three-Eye Atlas, disturbing as they were to our understanding of causality, had a kind of beauty to them, a symmetry between future and past that appeals to something deep in our consciousness. As you drift deeper into the realm of sleep, where logic relaxes and beauty becomes more important than explanation, the mystery of Three-Eye Atlas seems less problematic and more natural. In dreams, effects routinely precede causes, objects fragment and reform. Things disappear and reappear without explanation. Perhaps dreams are showing us a truer picture of reality than our waking logic allows, a reality where mystery is fundamental, where questions are more important than answers, where beauty is the highest truth. The question, did Three-Eye Atlas arrive before it left, might not have a yes or no answer. It might be like asking, what is the color of Wednesday? Or, how much does love weigh? The question itself might be more important than any answer. Might be teaching us something about the nature of questions, about the limits of language, about the boundaries of human understanding. It might be a koan, designed not to be solved but to break us free from conventional thinking. Some questions are doors rather than puzzles. They don't have answers waiting behind them but lead to new rooms of possibility, new spaces of thought we didn't know existed. Three-Eye Atlas opened such a door, showed us a room we didn't know was there, a space where time isn't quite what we thought, where causality has more flexibility, where the impossible becomes possible. We're still exploring this new room, still mapping its dimensions, still discovering what it contains. The beauty of this new space is that it's large enough for everyone. Scientists explore it with equations and observations. Philosophers explore it with logic and argument. Artists explore it with imagination and intuition. Everyone who has wondered about Three-Eye Atlas has added something to our collective exploration of this new territory. It's a democratic mystery, accessible to anyone willing to wonder, to question, to imagine. The fragments of Three-Eye Atlas, in their final moments, pulsed in a pattern that some researchers have compared to the golden ratio, the mathematical relationship that appears throughout nature and art. This might be coincidence, pattern-seeking minds finding meaning where none exists. Or it might be a clue, a hint that Three-Eye Atlas was connected to fundamental patterns that underlie both physical reality and aesthetic experience. The beauty of the unanswered question is that both possibilities remain open. As weeks turned to months and months to years after Three-Eye Atlas's disappearance, the immediate excitement faded but the deep wonder remained. The object became less a news story and more a permanent feature of our intellectual landscape, like dark matter or the origin of life. It joined the catalogue of things we know we don't understand, mysteries that humble us and inspire us in equal measure. It became part of the background wonder that makes science worthwhile. Graduate students now write dissertations about aspects of Three-Eye Atlas that their advisors never imagined. New theoretical frameworks are being developed that treat retrocausality as a fundamental feature rather than an anomaly. Experimental physicists are designing tests that might recreate pre-echoes in the laboratory. the mystery has become a generator of new science, new questions, new possibilities. Even if we never fully understand 3i Atlas itself, the search for understanding has already yielded tremendous value. The beauty of unanswered questions is that they remind us we're still at the beginning of our journey of understanding. Despite all our knowledge, all our theories, all our sophisticated instruments, we're still children wondering at the cosmos. 3 Atlas was a reminder of our youth as a species, our ignorance as individuals, our potential for growth and discovery. It was a gift of humility wrapped in mystery. Some scientists have suggested that unanswered questions might be necessary for consciousness itself. If we understood everything, if there were no mysteries left to solve, would we still be truly conscious? Or would we become something else? Something that knows but doesn't wonder, that sees but doesn't question. The beauty of unanswered questions might be that they keep us human, keep us growing, keep us alive in the deepest sense. The search for answers to the 3i Atlas mystery has led to unexpected discoveries in other fields. Techniques developed to analyze its pre-echoes have been applied to earthquake prediction, finding subtle precursors to seismic events. Algorithms created to track its fragments have been used to study disease spread, identifying patterns in complex systems. The mathematical frameworks developed to explain its behavior have found applications in quantum computing and cryptography. Even unanswered questions can yield practical benefits, but the greatest benefit might be the wonder itself, the expansion of our imagination, the reminder that reality is far stranger and more beautiful than we knew. 3i Atlas was like a key that unlocked a door we didn't know existed, revealing vistas of possibility we hadn't imagined. Even if we never fully understand what we're seeing, the view itself has value, changes us, makes us more than we were. As you continue your descent into sleep, the question of 3i Atlas becomes less urgent, more contemplative. Did it arrive before it left? In the drowsy logic of approaching dreams, the question seems to answer itself. It arrived and left simultaneously, existed in all moments of its journey at once, was always arriving and always leaving. This might not make sense to our waking minds, but it has a deeper truth, a poetic accuracy that transcends literal interpretation. The beauty of unanswered questions is that they connect us to the infinite. Every answered question is finite, limited, closed. But unanswered questions open onto endless possibility, infinite mystery, boundless wonder. 3i Atlas connected us to this infinite through its finite passage through our solar system. It was a bridge between the known and unknown, the possible and impossible, the question and the answer that exist in eternal tension. Somewhere in the universe right now, other mysteries are unfolding, other objects are violating expectations, other phenomena are challenging theories, other questions are being born that won't be answered for generations, if ever. The universe is generous with its mysteries, always providing more questions than we can answer, more wonder than we can exhaust. Atlas was just one gift among countless others, one beautiful question in an infinite cosmos of questions. The pre-echoes have faded, the fragments have vanished, the immediate mystery has passed into history. But the question remains, beautiful in its unansweredness, profound in its implications, eternal in its wonder. Did 3i Atlas arrive before it left? The question echoes through human consciousness like the pre-echoes themselves, arriving before we're ready, lingering after the source has vanished, connecting past and future in ways we don't fully understand. As sleep finally takes you, carrying you into the realm where all questions and answers merge into dream, you can rest in the beauty of not knowing. The universe doesn't require us to understand everything, doesn't demand complete comprehension. It offers mysteries as gifts, questions as treasures, wonder as sustenance for consciousness. 3i Atlas was one such gift, and its unanswered question continues to nourish our curiosity, our humility, our sense of awe. The story ends where it began, with a question that acknowledged doubt but builds gentle intrigue. What if an object from interstellar space could announce its arrival before it arrived? What if we detected echoes from tomorrow? What if causality is more flexible than we imagined? These questions don't have answers, might never have answers, but they've already changed us, already expanded our conception of what's possible, already enriched our understanding of our place in the cosmos. The beauty of the unanswered question is that it never ends, never closes, never stops inspiring wonder. Long after the last scientist has analysed the last bit of data from 3i Atlas, long after the last theory has been proposed and tested, the question will remain, did it arrive before it left? And in that question, in that beautiful, impossible, unanswered question, lies an invitation to wonder that will last as long as consciousness itself exists to contemplate it. Tonight, in your dreams, you might find an answer that can't be put into words, an understanding that transcends language and logic. Or you might find new questions, even more beautiful and mysterious than the ones we've been asking. Either way, you'll be participating in the grand human tradition of wondering at the cosmos, of asking why and how and what if, of refusing to accept that reality is simple or fully knowable. The universe has given us many gifts, but perhaps none more precious than mystery itself. 3. Atlas was a perfect mystery, arriving unexpectedly, behaving impossibly, disappearing completely, leaving only questions in its wake. It reminded us that we live in a cosmos far stranger than we imagined, far more wonderful than we dare to hope, far more mysterious than we'll ever fully understand, and in that reminder, in that gift of wonder lies a beauty that no answer could ever match. Sleep now, carried on waves of mystery toward dreams of impossible objects and beautiful questions. Tomorrow you'll wake to a world that seems solid and comprehensible, but you'll know better. You'll know that beneath the surface of the everyday lies a reality so strange that objects can arrive before they leave, so wonderful that the universe can surprise us after centuries of observation, so beautiful that even unanswered questions are treasures worth cherishing. The question echoes into silence. Did 3 Atlas arrive before it left? The silence that follows isn't empty, but full of possibility, pregnant with wonder, rich with the promise of mysteries yet to be discovered. In that silence, in that space between question and answer, between known and unknown, between possible and impossible, lies the true gift of 3i Atlas, the reminder that the universe is far more magnificent than we ever dared to dream, and that we're blessed to be conscious witnesses to its unfolding mystery. And so we end where we began, with wonder, with questions, with a quiet recognition that we live in a universe that doesn't owe us explanations but gives us mysteries instead. 3i Atlas came and went, appeared and disappeared, arrived and left. Perhaps in that order, perhaps not. The beauty isn't in knowing, but in wondering, isn't in answers, but in questions, isn't in certainty, but in mystery. The cosmic visitor has passed, but its gift remains, the beautiful, unanswered question that will echo through human consciousness as long as we exist to contemplate it. The universe continues its patient unfolding, its generous distribution of mysteries, its quiet revelations that we're part of something far grander than we understand. And in that grandeur, in that mystery, in that endless provision of beautiful questions, we find not answers but something better. Wonder that never ends, curiosity that's never fully satisfied, a relationship with the cosmos that grows deeper with each unanswered question. 3i Atlas was a perfect teacher, instructing through mystery rather than clarity, leaving us not with knowledge but with something more valuable, the recognition that the universe is inexhaustibly wonderful, eternally mysterious, and infinitely worth exploring.